About now? Let's see whether you can see me or hear me. No. You can see me, right? And hear me. Check, test. Nice. Ah, finally. I don't know why, but it works. So I just have to restart, right? Yeah, I'm pretty happy about everyone here. So welcome to the second day of Bootcamp for Databricks. I'm really excited about the second day because it's going to be a heavy day, to be honest. I've prepared a few stuff for you, but to be honest, I thought the longer I prepare, the longer I'm gonna forget. That's why it's gonna be open session. I will explain everything, try to explain everything that I know about data engineering in Databricks. I saw that most of you did enjoy yesterday. I saw as well the engagement yesterday on the chat and the questions. And in Discord as well, we have a lot of new visitors to Discord, so I'm really happy about it. So yeah, welcome to day number 2. And I'm gonna ask maybe first question, do we have here any new people joined today and you were not yesterday in our session? Is it your first day now in the data camp? Let me see in the chat. There is always like a 5-minute delay or something. 5 seconds delay. The voice is glitching, right? Okay. Yes. So is still the voice bad, right? I have to maybe to try something. Wait just a second. Strange, I didn't change anything since yesterday. So now I hope the voice is better and you can hear me better now. Okay, voice is very good. So that's good. Yeah, so today is the data engineering parts. And yeah, welcome everyone to the data camp. Bootcamp. Now, one thing before we start in the session, I want to mention as well, in all those sessions that I'm doing now about Databricks, it's not about that I'm going to teach you how to use the UI, how to use the tool. I'm just providing you, let's say, the mindset behind using the Databricks, why we are using this tool. And if you were yesterday in this session, you understood that I like to talk about the theory. I like to talk why we have this tool, because to be honest, you can get everything about Databricks, but the tool might disappear over the time. There is a lot of tools that I used previously in my career that totally disappeared and died over the time. So it's not about learning the tool, it's about having the mindset. Because once you have the right mindset on how to do data projects, then you can then move to any new tool, okay? So it's not about the tool, it's not that the Databricks gonna make, let's say, gonna make your company works perfectly with the data and stuff like that. It's just a tool. If you are good with the tool, you have the right mindset, then you can do good projects. But if you don't have the basics, you don't have, let's say, the right mindsets, you might do as well bad stuff using Databricks. So that's why I try to mix stuff between the concepts, the idea behind the scenes, and as well the tool. So that's why we're gonna now start with our with our plan. I'm gonna go and share my screen now. Let me just go over here. And yeah, so back to our roadmap. What we have done yesterday is the following. Let me just move the chat so in order that I can see whether there's any issues with the voice. Yeah. So now, this is our roadmap for Databricks. By the way, you can just copy the roadmap and you can adjust it the way that you want. So it's not static. You just have to install Notion and duplicate the roadmap and then adjust it the way that you need. So it is split it into 2 sessions. Yeah, the data analytics, that was yesterday, and the day 2, it was about the data engineering. And yeah, I think we have covered a lot of topics yesterday. So the module 1 was Introduction to Databricks, and the module 2 was about the data analytics, but there is 2 things that I didn't cover, and that is Power BI with Databricks and the notebooks. Now about the notebooks, today I'm gonna give you an introduction to the notebooks. So that means if you are a data analyst here, you don't have to worry about it. And yeah, I'm gonna show you how to do that, but with the data engineering part. Now about Power BI, I want to say a few words about it, just to let you know how to connect Databricks with Power BI. And then we kick off the module 3, where we're going to talk about data engineering. To be honest, this is my first time I'm doing those bootcamps, so I don't know how long it takes. Yesterday, I said we're going to take about 3 hours, and we took 4 hours. So I'm going to go as much as I can, and as long as I have energy and you guys are here, then we keep going, okay? So now, the way I'm going to do it, I will think that you are a friend sitting near me here, and I'm explaining stuff that happens in the work, okay? So there is nothing like structured or PowerPoint or stuff. I will just go and start like clicking around and show you around to make you confident with Databricks. Now about the Databricks, one more thing. You don't have to install anything locally at your PC. It is something that runs on the cloud. So we will not use anything from your resources at your PC. And you have just to create a free account by Databricks. It is available since few months only. Before you had to pay to try Databricks, so it's now free. And yeah, so you can create an account on it. You can find all the links in this Notion roadmap. And one more thing, this is not sponsored by anyone, okay? So this is not sponsored by Databricks. If I say something good about it, then this is my opinion, and I'm not trying here to push the Databricks, because I believe this tool made things easier for us, for data engineers and data analysts. And yeah, but I am not attached to this tool, yeah? So if I found better tool in the future, then I'm gonna go for that. So that's it. And one more thing, by the way, I would like you to one more thing before we continue, that's to support the channel, please. So if you go like, maybe share, subscribe if you don't have already. I checked yesterday the analytics. It says around 70% of you are not subscribing for the channel. So I'm doing this in my now weekends on, let's say, on the time that I could spend here with the family and stuff. So I would say support the channel if you can. Just yeah, subscribe and stuff. It's gonna improve the channel to reach the others. So now, this is totally for free. Again, you don't have to pay anything, not for the bootcamp, not for the materials. I'm going to send you a lot of stuff as well after we are done with the session. And yeah, let's go. So I'm going to cover now one topic before we continue. It is the Databricks and Power BI. And then we go to data engineers. So data engineers, if you are here, pair with me. And by the way, as a data engineer, you should learn Power BI. I used a lot of Power BI while I'm working with Databricks as a data engineer. So data engineers, you still have to do something with the Power BI. Yeah? You can create a lot of monitoring stuff, and you can analyze your data, your pipelines using Power BI. So it's something relevant for you. Okay, so now, if you are new here, you're gonna be shocked, but we talked about this yesterday. So we talked about, as a data analyst, you can use SQL editor, you can create a dashboard, you can use the AI Genie. But I said always, if you are creating standard reports, still Power BI is a winner here compared to the dashboarding that you have Databricks. It's not, they are not competitors between dashboards of Databricks and the dashboard in Power BI. They just are used in different purposes. We use dashboards in Databricks only for explorations purposes, but the Power BI standard reports, it is for the standard users. Yeah. So now, in order, like how are we gonna do this? Let me just start something here again. So now it's gonna be very simple. So you have here the, let's say, the Databricks code layer. Okay, so your data inside Databricks, and you are doing the AI Genie, you are doing exploration, doing SQL and amazing things. But now what you can do, you can go and grab a Power BI, and you can treat Databricks as any source for data. Like, think about it like database, okay? So you don't have to, like make it complicated. Now, in order to connect, let's say, Power BI with Databricks, you have here always the connection. I talked about it in the last videos in Power BI. So you have here either to say, you know what, I'm gonna go and pull the data from Databricks and put it in Power BI. So you're gonna go and use the import mode to import the data inside Power BI. And this is the default. So this is something that you're gonna do, I'm gonna say, as a default. If things goes inside Power BI and you have, let's say, no issues with the import time, with the, let's say, load time inside Power BI, then go always with the imports. Because the other scenario gonna be a little bit more expensive. If you go and say, you know what, I'm gonna go and attach Power BI directly to the Databricks using the direct query. So direct query, you're still gonna get an amazing performance, yeah, in Power BI, because the infrastructure behind the data using that direct query is amazing. So this, if you are using Databricks, the answer time for your query is gonna be very fast. So that's why direct query with Databricks is, I think, the best option you have for this connection type, because Databricks is completely based on Azure, okay, or AWS, and the infrastructure is very stable. So that means you can go and use that direct query only for two cases. First, if you have real big data, like huge amount of data, and you are not able to use the imports. So if, let's say, you have 3, 4, 5 gigabytes of data that should move inside Power BI, then the import gonna be very slow for you. So if your data is really big, I can tell you, we connected almost 40 projects to our the Databricks. I can say most of the projects, they managed to do the imports. So it's only few projects where they said, you know what, it's we have really huge data and we should use the direct query. So only if you have exception, you have big data, then go with that direct query. And the second one, if you have a real stream. So if you have here stream data inside Databricks, then of course you cannot go and refresh the data like each minute or something like that. Then you have to go and use direct query. But I can tell you from many projects that I have done, it was more than enough to use the imports. So this is how, let's say, we configure the two tools. And of course, having those two tools is more than enough to do any standard reporting. And the connectivity is very, very simple. I'm gonna show you, let's go back to Databricks again. So now, of course, the data gonna stay on the Unity catalog. So if you go to the catalog, you still, I think from last time we made the sales DB. So our data is inside the Unity catalog of Databricks. And now, of course, we're gonna use some kind of computing in order to send the data to Power BI. And that's, we're gonna use usually the SQL warehouse. So currently it is offline. I'm gonna go and start it. Always keep your eye on the execution of, or let's say, whether your server is started or not. So I'm gonna go and start it. And now, what is very important here, if you go inside, so again, I'm clicking on the serverless starter warehouse. If you go and click on it, then you're gonna see more details about your server. And this is very important because we're gonna go and connect Power BI to this server in order to pull the data. Okay, so that means we're going to go to the connection details over here, and you're going to see here it's already telling you from Databricks, okay, you can go and connect this server with Tableau, Power BI, dbt, Python, and a lot of things. So this is usually the way where we connect Databricks with many other tools. We go and use the SQL warehouse. And we're going to use now the same thing for Power BI. Now, of course, you can go and click on this here in order to get the file. Or if you go and start Power BI desktop, let me just start one. So now if I go to blank report, it is very simple. So all what you have to do is to go to get data and then to more. And just search for Databricks. So once I do that, I will get two instances, one for Azure and one for Databricks. Now the free edition is totally based on the AWS. So that means we will not use the first one. We're going to use the second one, the Databricks without Azure. But if your project is based on the Azure, then you have, of course, to use the first one. So we click on the Databricks, connect. And now comes exactly here the information that we need from the server. So it's pretty simple. It says, okay, I need the server host name. I'm going to go and get the server host name, just copy it from here and paste it over here. Then we need the HTTP, the second field here, the path. And we can go over here, grab it, and then paste it over here. And actually that's it. You need only those two informations. Everything else, leave it empty for now, and then click OK. Just wait a second until it connects. It's not happy about that. I think it takes some time until to connect to Databricks or so. Let's see. So yeah. Connect. Oh yeah, now it's loading. So now I'm gonna, I think, yeah, so look at this. I'm connected now to Databricks over here. And what you're gonna see here now is exactly the preview from your Unity catalog. So whatever now I see here, the workspaces, is exactly the workspaces that I have in Databricks. So now this is what we have done yesterday. We loaded the files into Databricks, but we haven't done anything to those files. So that's why, so I can go and grab, for example, the customers, and now it's gonna go and load the data inside Power BI. And with that, actually, my friends, you can connect Power BI very easily using, this way. So I will not go now and build any dashboard or report because we have here data engineers that want to hear about engineering. I just wanted to show you this point, how to connect Power BI to Databricks. It's very simple again. You're going to connect your data from the catalog, and you're going to go to the warehouse. Inside the warehouse, you're going to find the connection string, and either you click over here on those connectors, or you just copy and paste the first two options, and then you can enjoy the two platforms, the Microsoft Power BI with the Databricks. And with that, I will not, let's say, keep, speaking about this topic, but again, mostly, let me just recap finally over here. So now I showed you this data analytics maturity, and most of the activities that you can do as a data analyst, you can do it using the Databricks. So you can clean data, you can do ad hoc reports, you can do self-service, and as well you can chat with your data using Databricks. But the only thing that I don't think it is ready is to make standard reports for massive amount of users. You still has to use Power BI. So with that, I hope that we closed this topic, and and I hope it's clear for you about the Power BI. Yeah, I wanted to make a report yesterday with Power BI, but we spent 4 hours, so that's why I will now just close the topic and I can be happy now. I showed you at least how to use Power BI with the Databricks, when to use it, this is very important, and the connection type. Be careful with the connection type, because direct query gonna cost a lot of money for you. If you keep sending queries to Databricks and each time Databricks using resources, it means you're gonna see it in the invoice by the end of the month. So pay per use. Now, I think we are ready or let's say we are done with the data analytics parts. Now, about the notebooks, as I told you, we're gonna cover it now during the data engineering part. And yeah, so now data engineering, we're gonna start from the scratch, guys. I thought about it today. I was thinking about today whether I do only the projects for you or I do the whole thing. But I felt it's gonna be really not clear why we are doing the projects the way without giving you the concepts. That's why I still believe we have to do the concepts, but I hope that we can do it in these 3-4 hours. So let's start with the basic idea. I have prepared, as usual, a few stuff for you. Now, we said we have something called Lakehouse, okay? Maybe this is not really clear for everyone, what is a Lakehouse and stuff. So I'm gonna give you like the way how things developed or grow over the time. At the start, my friends, we had data analysts, or let's say business users, having questions. Maybe if you saw my introductions to, let's say, how data teams works, I always start like this. Yeah. So we have business users having business questions, okay? Now, your data analyst usually at the start, if we don't have plan in the company and the company don't have any strategy about the data, they're gonna send their data analyst and they start making Excels left and right. And of course, over the time, we're gonna have a lot of Excels left and right. There is no data management. The data is old. The data makes no sense. The answers are, let's say, different from one Excel to another Excel. And yeah, this analyst needs like at least a month in order to prepare the data in the Excel. So the companies, if they don't have plan about the data, they just do analytics using Excel. It's gonna be full chaos. And I can tell you it's gonna be expensive. And those people, the business users, gonna make at the end wrong decisions. Now, I can say still companies doing this until now. But the thing is, inside the company, especially if it's big, you're gonna have people that are doing some advanced stuff using modern platform, but still there is a lot of departments still using Excel. That's why we said we will not do this anymore. Data analyst is going to go to the right side a little bit. We're going to hire data engineer. Do I have here data engineer? No. So now let's grab maybe someone like this and say, you are a data engineer. Actually, at the start, we didn't call you a data engineer. We called you an ETL developer. So actually, we didn't have this name or this title. You called ETL developer. I was ETL developer at the start. So I got hired as the ETL developer. And my job is to do one thing. They told me as data engineer, hey, go and grab the data from those multiple systems and put it in something called a data warehouse. So I used the tool called Talend, and I start grabbing the data from the multiple source systems, and I start doing a process called ETL. So what is ETL? It means I extract the data from the source systems. This is the E. The T, I start preparing the data, transforming it, cleaning it up, and then I load it to the data warehouse. So I've done that, let's say, yeah, in few projects in order at the ends to build a reports. Or let's say the data analyst or the BI developer gonna go and build a reports, a data analysis on top of the data warehouse. So I'm gonna say at the start, I was an ETL engineer, ETL developer, sorry. So all what I need is storage, like data warehouse could be inside SQL Server, inside Oracle, and I start saving the data inside the warehouses. Now, this is a big issue. This is a big issue over the time. The thing is, over the time, those sources were getting bigger and bigger over the time, and as well getting more complicated. Like, for example, one of the sources says, you know what, we will not give you an access to databases. This is not something that we do anymore. My data is inside Kafka. We stream, we are now modern, and we stream data. Then me as an ETL developer, data engineer, I didn't have the enough tools to start streaming the data from Kafka inside this data warehouse. It is really hard. Like, try if you have an on-prem system. I think I had some glitch. So now, I hope I'm back. Yeah, I think I'm back, right? So now, as an ETL developer, once I start facing complex systems like Kafka, like APIs, like stuff like that, they start, like, it was almost a hard job for me, and I was not able to do this because I don't have the tool for that. And then starts we getting like some kind of, I don't know, images. I'm back. Sorry for that. My graphic card was not happy at all. So I have to restart. Can you still hear me or see me? Yeah, okay. Yeah, today I'm not happy with the technique, so sorry. I'm gonna immediately open everything again. So just give me seconds and then start sharing again. Dun, dun, dun. Notion. Yeah, I was doing like 1,000 things parallelly, streaming and recording, and I don't know, the things as we're not happy. So let me just open Notion again and we continue. Sorry for that. Or maybe because of Power BI, you know what? I can blame Power BI. It disconnected me. So almost there. Streaming. Yeah, I should. So then I think, yeah, so the visuals are there. I'm happy about it. So again, sharing my screen. You are able to see this, right? Okay. Yeah, it's Power BI. So, okay, so as an ETL developer, I struggled with a new technology, all right? And I was not able to fit everything inside the warehouse. And guess what? Guess what? We start getting a new people that want to consume the data. So the data scientist and some power users from the business, they started asking for crazy stuff. They said, you know what, the dashboard that you are building, not really exactly the thing that I need. Give me an access to your warehouse. So people start not be interesting on the PI section of my data system. They start asking about the data warehouse section, okay? So that's why it was full big issue. And over the time, most of the data warehouses get so big that you can't load it anymore, because I saw at least 3 projects where they load the data every day for around 12 hours or 20 hours it takes to load the data from A to B. 20 hours every day. So data warehouse project starts to fail, guys, because of the sources and because of the new demands. the data scientists were interested, on data warehouse to make some moduling, and they start asking, hey, go and grab for me the files that you have in the sources and stuff. So the data warehouse, as classical warehouses, start to fail. And that's why we start seeing some new titles like big data developer or data engineer developers, where we said, you know what, databases are really crap to build a data platform. Let's go and not use it. So I'll just go and copy the whole thing. And then we talk about the next step. It's around 2010. Okay, so 16 years ago, we start doing the following. We say, you know what? In order to fulfill all those requirements, we're going to go and build a data lake. So now, me as data engineer, I don't need database. I'm going to go and have a very, very cheap storage, like the blob storage, and I can pull whatever you wish. I can pull databases, Kafka, images, videos, JSON, whatever you want. I'm going to go and pull it and put it in one place. But guess what? I will not do any more the T for you. The transformation, go and do it on your own. Just, I am now the loading master. So we start saying, you know what, I'm going to go and put everything in one place. It is cheap, it is fast, you have everything. And everyone needs the data, can go and grab their data. Yeah. So the data analysts start accessing this data lake, the scientists, power users. So they start accessing the data lake, but we have noticed this T, it is the biggest problem actually, because the transformation, preparing the data, it is one of the most annoying step on the ETL, because the data is very, very raw. I can tell you, I spent on one of the projects, like only one source at Mercedes-Benz, I spent half a year just doing the T as a data engineer, because the system is very complex and I have to do a lot of preparation steps to make it friendly for the BI, for the AI. So doing the T actually is the most hardest part. And now imagine that you collect the data for the company, put it in one place, and each new projects, they have to go and make the big T. They have to do that transformation. This is the heavy lifting. And they will keep repeating, doing the same stuff over and over and over. And this is not working. That's why data lakes at the end, they were like, let's say at the end, just a garbage where you put data inside it. And it is very costly for the T. It's not costly for the storages. It's very cheap to do data lake. But the process after that, it was very expensive. So imagine, like in my project, I done transformation for one source system 6 months. And imagine we connect 40 projects. So 40 projects, they have to do 6 months of transformation, each one of them. You know, so when they're going to do the BI, when they're going to do the AI stuff, it is not possible. That's why data lakes are crabby. They are a failure, to be honest. And yeah, if you just start doing EL and wish that everyone else is going to do the T, they gonna fail. That's why, my friends, the T was really important for us as a data engineers to do. So we cannot, like, should we go back to data warehouses? Well, no. Still, we're gonna have the issue with the data warehouses that is expensive and that is not suitable for all different types of data, not scalable. So the idea is to do both of them actually, is to make some kind of data lake, but we're gonna make it together inside a warehouse. And we call this, let me just give the titles. So this is Data Lakehouse. Maybe the color bigger. So we said, okay, I'm gonna do both Data Lakehouse, and here we have what we have done here. Here we have done Data Lake, and here we have done the warehouse, right? So data warehouse. So now what we're gonna do with that, I'll just grab this away. just maybe to put the visuals side by side, for you, because at the end you're gonna get an access to those stuff if you like those sketches. So now what we said, we're gonna go and build Lakehouse. Just gonna grab this icon here and put it over here. And we said, yeah, okay, we still need everything to be fast. We still need some kind of storage that is accept any type of data. But my friends, data engineer, you still have to take the T back. So that's why they gave us back the T, which makes sense, of course. But yeah, so we started doing some kind of warehousing again, but on a new technology. So we said, okay, I'm gonna make now not only one lake, I'm gonna make like 3 layers. So this is gonna be the the first one gonna be the bronze, and the next one gonna be the silver, and the last one gonna be the gold. So now, and all of them are lakes. Yeah, all of them are in not databases. They are based on files. Let me just put this below. So all of them are in lakes, but I start doing some T in between. Okay, so I'm gonna, of course, at the start I'm gonna extract the data, load it in the lake, and then I start doing some transformations between those steps. So there are layers, and yeah, we call it bronze, silver, gold. You can call it whatever you want. You can call it stage, core, access, presentation layers. Like if you join companies, it depends on the data architects. They start giving it different names. Yeah. So if the guy that is doing, or the girl, of course, doing the data architects, one of them might say, yeah, this is bronze, silver, gold, and the other gonna say, this is the raw, this is the business layer. It like, yeah. At the end, we need layers so that we do things step by step. We cannot do everything in one place, okay? And yeah, then, my friends, you're gonna have the shape of Lakehouse. So you are mixing data lake with the Lakehouse. And now, currently, with these concepts, we are ready to serve anything. So now if the analyst comes and say, hey, I want to do data visualizations using Power BI, then you can offer them the final layer to say, okay, go and grab this gold layer and start doing your BI. Maybe you're gonna get data scientists and I'm gonna say, you know what, this T, the last T was not really okay. I need the raw data from the middle layer. So they're gonna go and access the middle layer, okay? But we will never give an access to anyone to the bronze because the bronze is really crappy. It is like the raw data and nothing is done. It's like the data lake. So that's why data lake, we don't give an access to it. We give something that is more prepared, more cleaned, that is more like, let's say, ready to be consumed. And I think it looks like this now. The data analysts, they grab the last form of your data because they want to spend less time doing steps, but the data scientists, since they are training models and doing AI stuff, doing machine learning, they need the raw data. The more data they have, the more they can, maybe train their models. Yeah, that's why I see it like this. And as well, the power users, they can decide whether they go to gold or to silver. So actually, we are giving now the access to either silver or gold to end users. The bronze, we are not giving it. So now, just to tell you, we spent almost 20 years just building warehouses, okay? Now, after 20 years, we start doing lakes around 2010. And the Lakehouse, it is something I can say brand new. It is something that's introduced actually not from, like the data lake and the data warehouse, they introduced from the universities, they introduced from science work, but the data lake house is introduced from actually Databricks. Okay, they are from the industry, and they said, you know what, my platform, you can use, you can mix warehousing and data lakes, and I believe it was a good idea. But we are not there yet because, to be honest, I can tell you something. We have a big struggle still until now. Like, I was a data engineer building this. I built this Lakehouse. I spent 5 years, like 2 years building Lakehouse. And then, let's say, still see some struggles on this. It's because those the transformations are really heavy for us. Because the transformation was done before from a data analyst or maybe data scientist. They know exactly what they need. But now, in case for us, for data engineers to do the transformations, we have to ask a lot of questions. We have to talk to the stakeholders, to the business users, to understand the processes. It is really hard for us, for engineers, to do the T's still until now, because now imagine you have here, I don't know, 20 source systems. You have to understand each one of them in order to make that T. So that's why either we're going to bring the data scientist or the people here to join us building this Lakehouse, and each analyst is going to go and turn to a business, or let's say data engineer, or we need solution. That's why still I'm not convinced that's going to be the final phase. And by the way, in companies, like in big companies, you will not have one central Lakehouse as one single point of truth for the whole company. Like, imagine company like, I don't know, Netflix or Mercedes-Benz. We will not put everything in one place. There is no way there is like a team can manage to do the whole thing. That's why there is a new concept as well 2 years ago called data mesh concepts. So what we say, the following: the company is very big. Now, each domain, they're gonna build their own Lakehouse. So domain 1, domain 2, and it's gonna look like this. So you're gonna have in the company, for each big domain, a central team that is building such a concepts, building data products, building the gold layer, but only for their domain. So for example, if I'm making the Lakehouse for the engineers of the cars, I will not go to the sales, for example, and start building their data Lakehouse, okay, as a data engineer. So that means as a data engineer, I'm gonna focus only on my domain, building the Lakehouse for this domain, and then, the others should deal with the other data. We will never make one enterprise, because the idea of warehouse and the idea of data lake is to make something like one data lake for the whole company, one data warehouse for the whole company. So that's why it is not working, and currently it is like this. It is splitting now by the domains, and you are building the domain-driven, let's say data products. And Databricks is exactly preparing for this, to build something called the data mesh. So data mesh. It is domain-driven, let's say, data architecture to make a data mesh. But in order to do that, you need two things. You need, my friends, I have an icon for it. Those two, come here. So now, in order now, like let's say I'm working as a data engineer, build very amazing gold products for the users. Now I have to tell everyone about my new data products as a data engineer. So that's why I have to put it somewhere called the marketplace in the company. So marketplace. And I need a catalog. So data catalog, right? So I need the catalog to explain my data. Like, for example, if a data scientist from a different domain comes and say, whoa, we have here a very perfect, let's say, data from the development. So first, the data scientist is going to go and browse the marketplace to see the data product, and then read about it, what is inside this data, and then gonna come to me and say, can you give me an access to that data? So that's why, without having in the company a marketplace for the data and the data catalog, it will not work. Now, Databricks is moving to this direction, because if you hear or if you see, we have something called Unity Catalog. This is the catalog that is available for the whole company. So now if I go in Mercedes-Benz, for example, and start, oh, I said closed my Databricks. I have to log in again. Just a second. Sorry for that. Log in. All right, just to make sure that I'm logging with my working account. I understood I am not allowed to use a personal account because this is considered as work. So now, if I go to Mercedes-Benz or to any company that is working with Databricks and click on the catalog, I'm gonna see here not only those workplaces, you can see here my organization. So I'm gonna see here huge amount of workspaces that are available. And this is exactly what Databricks is trying to do. We will see whether it's gonna be successful, but it is all about how the company gonna make the data strategy. But currently things looks good. We are able to use Databricks as a single point of, let's say, single point of platform to help us, but it's all about the people that are using the platform. So guys, this is the, let's say, the steps in the development of the data management. And you as data engineer, you have to understand those concepts to understand what you are doing. And by the way, guys, I really recommend you one thing. Try to not join projects or companies that are still doing warehouses. It's really, really important because let me just check whether everything is correct here. So now, if you go and join a company as data engineer, you have to understand where are they in this roadmap. Okay, so if they are still doing those stuff, it's legacy stuff. It's old. If it's your first job, of course, you can start building data warehouses, but try to target companies that are working on big scale, building lakehouses and stuff. And if you see in your company that they still are using warehouses, try to push them to move towards something more modern. And if you see someone in the company are saying, hey, data lakes, it's the best, I don't know, they are trying to build a data lake, try to push more to say this is garbage, because this is going to cost the company a lot. So if you as data engineer, you have to understand what you are building, not just blindly, let's say, building some old technology. And this is about the data management. And currently we are at this shape. And most of the companies are trying to implement this because this makes sense that each domain going to build their own. And this makes sense, not only lake, you have to mix it with data warehouse. And this is about the data management. I hope that was clear. I just want to check the chat whether you guys are hearing me clearly before I continue. Okay. Good. Now, let's move on. Let's move on to the next step. What do we have here? So that was about the data management. Now, about the data engineers, we covered few stuff, right? We start talking about the, how you work as data engineer. So we worked before, again, with databases, like my start before 15 years. We use databases, we use ETL tools like Talent. I don't know whether you know Talent. I don't know whether they are still here. Yeah, this year. So you have a lot of ETL tools that are in the market that are trying, let's say, to push on their on-prem solutions. Those stuff, from my point of view, are dead. So we are not using any more ETL tools. We are not trying anymore to build any data lakes. Now things moving toward Databricks, Snowflake, moving as well to data, stuff from the Azure as well, like Data Factory and Synapse and Fabric and stuff. So those are the tools that are supporting such kind of technology. Now, let's move to the next step where we're going to start talking about Databricks itself. I'm just going to go and do quick recap for the new people that are here about the this image here. Just quickly, Databricks at the end, it is just, from my point of view, a platform that supports the Spark technology. So they are the same team that's developed the Spark, where it's very simple. The idea, you cannot process the data in using one machine. It will not work. So you always need, let's say, distributed machines in order to process whatever you do, yeah, whether you are doing data transformations, data aggregations, and stuff like that. And it is very simple. The idea, you split, or let's say the Spark can go and split the data into multiple machines in order to work parallelly. So they work on parallelly, and then they're going to collect the data in the final result. This is currently, yeah, the best practices on how to process massive amount of data. Before we had the Hadoop, but the Hadoop issue was that only that we are using the hard disk in order to store the data. With the Spark, it is more, let's say, faster because we are using the RAMs in order to store the data. So actually, the Spark is just a distributed system using the memory in order to have speed. And now, since this is massive amount of work for you as a data engineer to make the setup, to make the things, that's why we have an easy platform called Databricks that hides the complexity from you. So the Databricks team gonna like, prepare everything in the background, and you as a data engineer, you're gonna be focusing only on the projects, on how to do the ETL, how to move the data. So that's why behind the scenes, it is Spark, and and you are using Databricks just to make your life easier. But if you don't want to use Databricks, of course, and you want to go, let's say, hardcore, you can of course use Spark and make, like, let's say, the configurations on your own. So actually, you don't have, if you are expert on this, you can make the configuration. You can buy the virtual machines from Azure. You can make the full setup with us Databricks. Yeah, but of course, imagine you have a lot of projects in the company, and each data engineer is going to spend a lot of time configuring the stuff before start building the ETLs, or let's say the data platform. Then this is a lot of time wasted. Yeah, so that's why this platform makes our life easier as data engineers, and we use it in order to process a huge amount of data. Now, we're going to go to the Spark. We're going to go now to the Spark stuff. Since I said the engine is from Spark. Now, there are like multiple concepts that you have to learn about. Let me just, this is going to be a little bit, let me just start from zero before confusing you, okay? So again, we have this amazing engine, the Spark engine, okay? This is going to deal with the whole thing. This is the brain, yeah? This is the heart of the Databricks. This one going to go and start spreading the task into multiple machines, start managing the memories and stuff. So this is the engine. Now, for you as data engineer using Databricks, or for you as a data analyst as well, now you have two ways in order to give tasks for this engine, okay? So let's say there's like two languages. This can get a little bit confusing, okay? So now, you can actually use only SQL. So you don't use anything else. You just go and select from where you just use SQL, nothing else. Not Python, not PySpark, nothing. Just simple SQL. And then there is like an engine called Spark SQL. The query going to be sent over here, and the Spark SQL going to go to the engine, and it's going to use the engine in order to do the query. So, and this is something, to be honest, Databricks team and the technology behind as well, the Spark, is pushing a lot in order to have you only working with SQL to build, not only to do data analysis. We saw yesterday, we can, as a data analyst, we can do data analysis, we can do queries and stuff. But now they are pushing as well that even you as a data engineer, you can use only SQL to build platform. But from my point of view, you can do that only for like not complicated stuff. Maybe you have 10 files or 20 files. Then I can understand you can use only SQL to build the data lakehouse. But if you want to do something professional, you want to do something that has complex logic, that is, let's say, can deal with multiple scenarios. You have Kafka, you have streaming and stuff. I still believe SQL is not enough. It's it's gonna make the code very huge. That's why we need Python. And we can use Python, of course, in order to build our projects. And inside Python, there is, let's say, a library or module that you can install called the PySpark. It's already installed, of course, on the Databricks because they expect you to use the PySpark. But you can use the PySpark in order to do the work, in order to work with the data. And the PySpark can look very, very similar to the SQL. So remember in SQL, you do select, you join tables, you merge tables, you filter the data, you do aggregations and stuff. So you're gonna find yourself that you are doing almost SQL, but with a new language called PySpark. And the same thing, if you write something in PySpark, it's gonna go and end up using the same engine. So people think, like I saw a lot of juniors, they start writing SQL in query and they think, you know what, I'm using SQL, this is very slow because it's SQL, it is not PySpark. But at the end, it doesn't matter. Whether you are writing SQL, whether you are writing PySpark in Python, at the end, everything is using the same engine behind the scenes. So if you are using SQL, that doesn't mean that it goes to something, I don't know, some old database, Postgres, or something that is very slow. No, everything goes back to the engine. This is important to understand, okay? So whether you are programming using Python, PySpark, or you are writing pure SQL, then this is totally fine. And there is one more thing. We can put SQL inside Python. So not only pure SQL statements, I can go inside my Python code and start writing SQL statements. So it's called PySpark SQL. Okay. So you can write purely only Python. Again, so what are the options? Sorry, it's confusing even for me to explain for you. So either you write only SQL, and this we call it Spark SQL, okay? So only SQL, or only Python using the PySpark, okay? Or you can use both of them together inside Python. So I'm using Python, but as a framework, let's say, and inside it, I'm gonna write a mini query. So this is we call PySpark SQL. So those are the three, let's say, different ways. By the way, if you write something in the PySpark SQL, it's gonna go to the Spark SQL and trigger this engine to translate the query, and of course, it's gonna use the engine. So, yeah. So actually, this is what we mean with all those stuff. So now you know what is a Spark SQL, you know what is PySpark SQL, and what is PySpark. Yeah, there are different ways for you to write a code in order to communicate with this amazing engine. Okay, so this is one concept. Maybe I'm gonna show you. Let's go back to Databricks. I'm gonna show you an example what I mean, what I'm trying to say, because this is gonna be otherwise very theoretical. Now, yeah. So now if we go back to Databricks, yesterday we learned a lot about the SQL editor, the dashboard, the Genie, and now today I showed you how to work with the Power BI. But for you as a data engineer, the most important thing is to work with the workspaces. The workspaces is something for you and you have to use it, okay? So I'm gonna guide you more about it. Now you can connect here GitHub, you can create multiple things. If you just go to create, you're gonna see, oh my God, there's a lot of things. So we have a notebook, a file, a query. So now the thing that you're gonna start using as data engineer is the notebooks. And here, yeah, I'm gonna guide you in the UI again, but just let me show you what I'm speaking about, those Spark and PySpark and SQL. So now here inside the notebook, if I say %SQL, and then I write a very simple query, select from, and then of course, I want to check what I have here, tables. So like this. Now, if I query this, what is going on? I'm writing Spark SQL. So I am here on the right side. I'm writing a Spark SQL. It goes to the Spark SQL engine. It's going to be translated and then sent to the Spark. Okay. It might take a little bit of time at the start because it's starting the server. But now, as you can see, it is working and everything now works again. Yeah. So now I'm getting the data. And again, I'm using now the engine that's called Spark SQL. Now, I can go and start using the PySpark engine. So for example, let's go over here and maybe I'm going to start writing some. First, I have to import. Let me just find a nice example for you. So for example, I'm going to go and start using PySpark SQL. And I'm going to import, functions. Now, I'm going to explain for you more details what I'm doing. I'm just giving you now an example, okay? So I'm going to go and create a data frame. Of course, you're going to say, what is a data frame? I'm going to explain for you that very soon. Now, I'm just reading the data again from my Unity catalog. So for example, I'm going to go and use the customers. So just specify the workspace, silver, CRM, cost info, or sales DB, then customers, and actually that's it. So I'm going to go and display df display. So now I'm using now not anymore SQL. As you can see, it is kind of Python with a PySpark. Now, as you can see, I'm getting as well the same results. So what I've done, I just went through PySpark and I used the same engine for the same data. So it is all the same thing. It's different languages that I'm using in order to query. And now the third way, I can put an SQL inside the PySpark. Let me just show you an example. So I'm going to go and make a new code. So here I'm going to say df spark.sql. And now I can go and write inside Spark simple SQL query, exactly like the first one. So let me just, So we're going to do the same thing, select from, and we're going to say sales DB, now workspace dot sales DB dot dim customers. And at the end, I can go, of course, and display. So display. So this is what we call, again, this is PySpark SQL. So I'm putting inside Python code an SQL statement. At the start here, I'm doing just PySpark. And the first one is just an SQL. So actually, you have 3 different ways, Spark SQL. So actually, you have 3 different ways on how to query the data. You just need to understand the syntax, of course. This is an SQL. And I'm going to do it here. You just have to understand the syntax, and it doesn't matter which one you use. Yeah, all of them going to get exactly same performance. They are using the same engine. It is just the way you talk to your data. So those are the different ways on how to interact, let's say, with the Spark. And I believe if you can only use SQL, I promise you I can do a project for this where we use only SQL. So create table, insert, updates, let's say select, aggregations, data cleanup, changing the data, everything we can do only using SQL. Of course, this is amazing. Like if I think about it and we go back, I don't know, 20 years ago, this is going to be a dream to use SQL to work with distributed systems. So now, of course, I have prepared those stuff, but I want to explain for you what is going on. So I want to do it always step by step. Otherwise, it's going to be let's say, shock for you. Now, so I spoke about something called DataFrame. So if you see here, I'm using something called a variable called df and DataFrame. DataFrame. It's something that you're going to hear a lot. And if you use Spark, PySpark, it is the main thing that we use to do anything. So the DataFrame concept is the most important thing to understand. And yet it is very simple. It is very, very simple thing. So now, all what we do as data engineers, we have a source table. So this is the source table. We want to take our data from the source and move it to the target, okay? So this is the main idea, what we do, move it to the target. But on the way, as we are moving the data to the target, we want to do some data transformations. So I want to transform the data, to clean up the data, to aggregate the data, to do the business. So now, in the concept of Spark or Pandas or whatever, it's not only for the Spark, okay? This concept is for many different, like for the Polars as well, Pandas, same concepts. It's gonna say, you know what? First, read the data from the source, put it in something called DataFrame. DataFrame, it is first in the memory, so it's gonna go to the memory. And anything you do to this DataFrame, it's going to be processed always parallelly. So it's going to go and always use, for example, Spark. If you are using Spark, of course. Pandas, there is no parallel processing. So the data frame is ready to be distributed on multiple machines. And if I do here, for example, data transformation, like I don't know what you suggest, like group by, or I'm doing a trim, or I'm doing an uppercase, whatever you do as data transformations, it's always like this. The data frame gonna be splitted into small data distributed on multiple machines. And they're gonna be processed for this function, and then they're gonna return, and then your data gonna be transformed. So data frame, it is something that is temporary. It's gonna live as long as you have the session open and you are using the data. So we take a copy from the data, we do whatever what we want on top of it. So we usually don't go immediately and do transformations directly on the source of the data, okay? We always take a copy. This is the main thing we do, okay? We always take copy. And here in the PySpark, we use a data frame. We do manipulation on it. So this is one. Oops. So this is the first thing. Then we do data transformations. And then 3, the last step we do is we write it somewhere else. And this is the concept actually for data engineering. Whatever we do, whether we are loading the data between the bronze or the silvers, always we have to think about those 3 steps. From where I read the data, I put it in data frame, I do something about it, or maybe I don't do anything about it, who knows, and then write it back. And of course, on the data frame, I can use SQL Spark, so I can use only SQL to do those stuff. Group by, trim, so the data transformation could be written as we saw inside SQL or using Python, PySpark. So, and this is the whole idea about the data frame. I don't know whether you know about the SQL concepts. I talked about the CTE, the subqueries, where the database engine gonna go and create a temporary storage of your data in order to be reused multiple times. So in reality, actually, this looks like once you start building things using Spark, you will be doing something like this at the end. Maybe it's gonna be more interesting. So you're gonna have like multiple steps, and this is gonna notice as we start building the project, okay, that I take the data frame from one thing to another thing. So I take the data frame from the source, then I do 1 transformations on top of it. So the first transformation, and then the output gonna be used in order to do another step. then the output going to be used in order to do another step. And actually that's it. Once you learn to do those stuff, you are actually, my friend, doing ETLs, and you are doing data transformations. Okay. Now, this is one more concept that you have to understand. So far we have learned about how to work with the Spark. What is the main thing about the Spark, like how we use the data, how we load it inside the data frames and stuff. Because if you don't understand those stuff, it's going to be really hard to understand why I'm creating now a data frame, why I'm doing those stuff. And by the way, if you are using Databricks, it's going to be always like this. The source of your data, yeah, between silver and gold, yeah. So the source might be a delta table, but we always try to load the data inside a delta table. So this is always the end format that we try to do, okay, inside Databricks. Always try to use this format. So we will never go and use, for example, CSV file to be written as a CSV at the end, okay? We will never do that. We use very advanced file format called delta table or delta files. Now, of course, if you want to be a data engineer on data lakes, there is a big difference, maybe just quickly to let you know why we have files, why we don't have like database tables. There is a big difference if you go over here. Maybe you can see a lot of SQL developers and stuff that are building warehouses. They load the data inside tables, inside SQL servers and maybe Postgres and so on. But we stopped doing that since the data lakes. In data lakes, we always store the data as files, okay? There is no more normal tables, yeah, like SQL. You have to understand there is files inside Lake. And even with the Lakehouse, we are storing the data inside files at the end. But of course, files has different format and stuff. And the format for the Databricks, it is an open format called delta table. So once you say, I'm gonna develop a data lakehouse inside Databricks, actually you are working with files, and you have to have some, yeah, basic, let's say, understanding on how to work with files. That's why I'm saying it is a delta table. Now, of course, you might ask, what is a delta table? Let's go to this image over here. So, delta file or delta table, whatever it is, there is two types of files. Yeah, there is closed formats, like the one that is stored behind the scenes in databases, and there is delta files there's the other type, the open files. Open file format, it is something that you can use wherever you want. I can take an open file and use it for AI, for PI, for analytics, for whatever I need. But the closed files inside the databases, they can be used only from the database engine. So like only inside the database you can use the files. But the open format, it's something that you can use everywhere. And this is the concept that developed from Spark, yeah, from the team. They said, we want to work only with open file formats. And one of the most, let's say, amazing file format that you can use called Parquet files. Parquet files are amazing for historizations. This is as well something that we have to do as data engineers. We have always to maintain the history of the data. We have always to have the possibility to travel back to the data to see the history, how the data was looking like. If you read about data warehousing, this is the main idea of building a data warehouse, is that I need as well to store the history of my data. And the Parquet file is amazing technique or amazing file format to do that. Now, at the start, as I start using Databricks, there were no delta tables. There were only Parquet files. Now, the thing is, if you start working with files, you're going to notice they are really not safe to use. Like if you do insert statements, if you do inserting new data, updating the files can get easily corrupted. It is going to be really nightmare to work with the files and stuff like that, to manage it, to maintain it. It is very risky. That's why they said, you know what, we're gonna add a new technique on top of the files to make it easier to be used, and as well to maintain some kind of safety, let's say, in order to do operations on top of the files. So now you as data engineer, my friends, we are not going anymore. Oh, let me grab a data engineer. So come here. So you as data engineer, you will not suffer anymore working with those Parquet files. You're gonna work with more advanced file format, or let's say technique, that's gonna make your life easy and safe on how you store your data inside those Parquet files, where you have something called delta tables. So you can use the PySpark technology to do very easy operations like create, read, how to write to those files, how to travel to the history, how to do audit, how to do optimizations using the delta tables, because they store not only the data inside Parquets, they as well use logs and metadata in order to store informations. And I can show you some examples about this. Now, if you go anywhere, let's say, and starting new query. Now, everything that I'm seeing inside the catalog, they are delta files, delta tables, okay? So they are actually behind the scenes, they are Parquet files together with logs and metadata, and I can do very easy operations on top of it. Like for example, if I go and say SQL, describe the history, look, the history of one of my tables. This is something that you will never be able to do in any normal database, okay? This is something that you can do only using this format. So I'm saying, describe for me the history of the dimension customers. So now it's gonna go and tell me, look to your data. It has actually 4 versions of your table. We have 4 versions. So we have the version number 1, where Bara did create the table. Okay, so this is me creating the table. This was the first version. The second version, Bara done some, I don't know. Actually, what is this? I added some comments to the tables. And then, yeah, I added few comments. So actually, the Spark is storing any interaction I'm doing inside the tables. The delta tables. So now what is happening, each interaction I'm doing over here, it is creating history, it is logging what I'm doing, it having some audit about it. And with that, I can go and visit. It's called, and I love this name, it's called time travel. So now I can go and time travel in my data and say, okay, I would like to work now with the version number 2. So for example, I'm gonna go and say select star from the workspace, blah, blah. And now I can say version as of 0. I would like to see my data as version number 0 at the start without any changes. So with that, look at this. I'm able to see the old history of my data. And this, of course, something that you cannot do in databases, not in Postgres or not in SQL Server. It is something that we do with the delta files. So as you can see, out of the box, using a very simple SQL query, look at, like, it's very simple. I'm saying only version as of 0. I'm able to travel to one of those old Parquet files, and I'm able to see the history. And now, because of the Spark SQL, I can do very amazing operations, like visiting the history, and I can do some insert, update, delete, like I'm working with any simple database. And that's why, as you can see now, how SQL is very important as a language, or let's say, yeah, as a way to interact with the data. All the companies, like not only Databricks or Spark is doing this. Like even if you go to Kafka, you can write SQL query in order to interact with very high-end, complex machines and stuff. And that's why I can say it's always SQL going to be very important even as a data engineer, because it is the way that companies tries to make things simple. And now, in order to do, of course, time travel, before I had to write some few lines in Python, yeah, in order to do those stuff. So as you can see, this is something that is, let's say, very easy to time travel. And one of the things that you have to do as a data engineer, of course, is to maintain those tables. Like, for example, this data here, yeah, my table. I created the table, I added a few comments. Now imagine how much operation is going to happen to your table, like inserting data, changing the columns and stuff. So the log going to be very, very big. And of course, the bigger the history, the more files you're going to get inside your Delta files, yeah? So you're going to get a lot of files, and things, of course, going to go slow, because each time, let's say, they're going to maintain those stuff, you're going to pay for the storage and stuff. So you have, as a data engineer, of course, to pay attention about how many files are inside your data. And that's why optimizations, it's going to be a big thing for you as you work with Databricks, to optimize your tables, to make sure things doesn't go and explode. Okay. So this is a very important concept. And one of the things that's as well, I think I made some overview about the operations that we do. Let me check. Do we have it here? Yeah, I have it here. Nice. So as you can see here, I just made like some collection of operations that you can do. It is very simple. So here you have, I'm going to say not Delta statement, I'm going to call it SQL. You can find it in Notion as well. You can do those operations that you usually do inside databases, like create a table, read table, append data, overwrite, update, delete. You can do either using SQL or using PySpark. And those operations, I think everyone knows how to do, right? Like, I don't want now to go through all those stuff. Just basic SQL stuff, right? Delete from table, yeah? Overwrite from table, append, and upsert. Time travel, I just showed you this time travel here. And of course, there's always PySpark version of each operations. So I'm going to say, of course, I will not do that now. If you want to learn PySpark, yeah, I'm not sure whether it is going to be very important always to learn the PySpark, because you can actually do a lot of things using SQL. Always you have to have in your mind how to map PySpark to SQL, and then you're going to get it. And you will not do crazy new stuff using PySpark. It's only few new stuff, like the time travel. It is new for you because you don't find it in normal databases. The history, the optimizations, vacuum. So there are some operations that comes from Spark, and you can do it in SQL. Just learn how to do it. And I want you to understand something that is really important, that to be honest, I interviewed a lot of data engineers, and I asked them always, like, what are the different ways on how to insert data inside Spark or Delta tables. So there are mainly 3 ways to insert data. I started to make sketch about this, but to be honest, it's not ready. So now there is, yeah, let me try to say, there is 3 levels on how to insert new data to your old table. So the first one called overwrite, like it's very simple. Overwrite, what this means, it's gonna go and, so this is the source, of course. Just let me add here, source. And this is your target table. The example is not really prepared, but I can just tell you like quickly. The overwrite, it's gonna go and delete everything previously that you have, and it's gonna go and take this as a new copy to your data. So whatever comes from the sources, it's gonna be the new data. So the old data gonna disappear, and the new data gonna be placed. So this is the overwrite. There is append, it is insert only. So you're gonna go and take the new data and just put it at the end of the old data. Okay? So this is append, insert only. So the old records will not be touched. Okay? So again, overwrite, the old data can disappear. We are replacing. The append, the old data will not be touched. no updates can happen. We are just appending. And the upsert, it is the way how we do incremental loads. So it's gonna go, yeah, the example, sorry for that, it's bad. So the example says here, or let's say the upsert, it says update first and then insert. So that means each row gonna be checked and gonna say, okay, do we have this record already? If yes, then I'm gonna go and update it. Otherwise, if it is not existing in my data, I'm gonna go and insert it. And this is something really important. Like if I rank those three, I'm gonna say append, I'm gonna say only in few use cases you can use append, only if you have like event. Like you have some sensors are giving you some data. And yeah, maybe you can go and use append only if you have sensors or stuff that's never change, okay? But usually we have to decide between overwrite and upsert in Spark, okay? And I can tell you, if the source system is very small, so small source system, then don't deal with the upsert. Upsert is a little bit risky sometimes if the day was bad and you didn't load correctly. So if you have small source system, just go and say overwrite. But now if you have a big source system, so if you have a big source system here, big source, of course, overwriting might take a long time. That's why you have to think about the upserts. And of course, that depends whether there is primary keys or not and stuff like that. And yeah, so upserts, it improves the performance where it's going to check first to update if the data exists. If not, then insert. And with that, only few rows going to be changed. The overwrite, it's good for small source systems. But anyway, you don't have to worry about the history because out of the box, you're going to get the history with the delta tables because we are already automatically like storing the bucket files. So that means I'm going to get always the history of my data. And this is amazing things. This happens a lot as well in my projects where the upsert was really bad or something went wrong in the target table. I just go and visit the history and grab the data from yesterday and then correct it and then do the operations again. So now those are the three operations, and as well, actually, you have for it some statements. So the overwrite data, where you're going to use the overwrite mode, the updates, and as well the update insert. And there is append, exactly. So you have all those three. And yeah, so I'm gonna say, let me check whether I have still some concepts that I would like to explain for you. Yeah, we're gonna talk about the notebooks. But now, how late is it? I think I would love to have a break before continuing, because next is gonna be, we're gonna start talking about some examples. So that means we're gonna have notebook. I'm gonna explain Lakehouse a little bit for you. And then I hope that you can manage it in 1.5 hours or 2 hours to build some kind of data lakehouse. I really want to build it with you, but I don't know how long it's going to take me. But I will challenge myself to do it. So I'm going to take a break now, 15 minutes. We're going to get back and start working on building the data lakehouse. I hope that makes sense. And of course, the questions we're going to do at the end, some Q&A, and I'm going to check your questions. So I hope that you enjoyed the first part of the session, and I hope that was not that complicated. Now let's take 15 minutes breaks, and I will get back to you. have 1 minute to go, and then we start. I look tired, yes. Too much screen time. I have. You saw this gift that I got in my 40th birthday? It's amazing. I have some toys. This one I got it from YouTube as a gift. It is like a Lego puzzles. You just like build it together. This looks nice. I have it always in the background. And of course the very famous Nescafe. I don't know why I have this cup, to be honest. 3 years ago I wanted to put something on my table. Yeah, at the start I drink some Nescafe, but then it just became part of my brand. Yeah, another gift from YouTube. So behind me, 3 gifts from YouTube actually. Thank you for your support, of course. No, it's all from YouTube. Okay. So I hope that everyone's back before I keep showing you my toys that I have here. I hope that I didn't get you confused with the roadmap. I just want to share something with you before we continue. So now, thank you so much for the donation. I'm not used to to check the donations and stuff, but thank you so much for that. So now, I developed, let's say, a new roadmap for you, for data engineers in Notion, and made a video about it. It's gonna be next Tuesday, where I describe exactly step by step how to do and how to learn the stuff. Like, for example, as you can see, the foundations is always SQL and Python. So it's really, you should have to learn all those stuff first. Otherwise, if you jump immediately to tools like Databricks, PySpark, it might get you confused. So that's why you have to learn the foundations. Then I take you in the next steps on which platform to learn and how to prepare to get interviewed, to get hired. And then I explain for you the next steps on your journey, not only like to get you hired, as well how to grow as a data engineer at the companies. The thing that you have to learn, the first steps in your job, yeah, like data security and things about the cloud, about the Kafka. So there's a lot of things to learn, but first the foundations. You need the foundations, you need the SQL and the Python, yeah. Without it, you cannot proceed with the next steps. So I was gonna share this roadmap I talked about it like around 35 minutes. So it's gonna be published in Tuesday. But now we are talking about our roadmap, our Databricks roadmap. So let's go back here. Let's continue. So I introduce you to a lot of things. And I can tell you, if you understood now from me around 50% of what I said, it is more than enough as a junior. Those stuff, let's say, it's something that you're gonna learn during the job as you are doing the project and stuff like that. I didn't learn this on my own. As I'm doing the project, I was introduced, or I heard about, okay, there is a Delta Lake, there is Delta table. So I start reading about it. So I wanted to give you in one shot everything, and whatever stays, the 50% that stays now in your head, this is more than enough as a junior data engineer, okay guys? Because you're gonna learn those stuff as you do projects. And I tried to push on you, or let's say on those concepts, just to understand the fundamentals. But of course, as you are doing the project, you will not notice like how the data is spread to multiple machines. There's a lot of, like even here, those files and stuff, it's gonna be behind the scenes for you. but I need you to understand when I say optimizations, or when someone say history of the files, you have to understand the concept behind it. So that's why I was trying to push on you on that concept. But as you start doing the first projects, it's gonna break the ice. You're gonna understand the whole thing, okay? Now, we can do now a project. And of course, this, like, I have done the same project in the SQL. It took me around 5 hours to just explain how to do the project. So that's why I'm gonna try now to do my best to explain how to do the project, so that you have enough knowledge to do a project on your own. This is very important. I want you to build a lakehouse at your end. It is totally doable. It is not that hard to do. I'm going to give you the scripts at the end of the bootcamp. I'm going to give you the whole scripts on how to do the lakehouse. Of course, there are levels of lakehouses, okay? There is an advanced one, there is a medium, there is an easy one. I want you to start with the easy one, where you build a data lakehouse based on files and CSV files. Not based on Kafka, on APIs and stuff like that. This is something that you can do as a next step. So I wanted to do a very simple lakehouse and to go through all the phases as I do in my projects. So what I'm going to show you now, it is something that if now I get hired again somewhere, I'm going to do exactly the same steps to build their lakehouses. And I will try to show you this. Now, this is like my perspective on how to build it. There is no like one book or one way how to build a lakehouse. There is no standards, okay, how to do it. Depends on the situation, depends on the scenarios, depends on the sources, on the company itself, and the data architects. Depends on the scenario you build it. But I'm gonna give you now, after a lot of, let's say, 5 years of building it, I can give you now immediately the last version where I built a lakehouse. I made around from the system that I have built 5 versions of it. So I migrated my lakehouse 5 times until I got the last shape of it, because there is a lot of variants, a lot of options, that's trade-offs and stuff. Yeah. So I'm going to show you now a way that comes from the industry that works, and exactly as I left 3 months ago. Okay. So this is I would say the way that I would do it. You might face another projects where they do it a little bit differently. They give different names, but at the end, to be honest, it doesn't matter. At the end, we prepare the data for others. Now, in the projects, the first step that you usually do is that you have to make a picture for you on how you're gonna build the project. You cannot go immediately and start scripting. This is the last thing that you do, okay? You have first to design a lakehouse for you. So now, if even you start a demo project for you, or even if it's like only the portfolio project, you have to build one big picture for your project. You have to have the concept, and then you start implementing. Otherwise, it's gonna be messy. It's gonna be like full of crap. So that's why, my friends, you have to build something like this. Of course, you can use the tool that I'm using here, or I recommend you to use the Draw.io. This is as well an amazing tool to build an architecture. If you followed me in the SQL warehouse, you're gonna find me building a lot of Draw.io diagrams. It doesn't matter which one. Take just, I don't know, yeah? Whatever tool you want. There is no standards for this. Now, you have to design, usually, we design for the lakehouse 3 layers. The standard says, okay, call it bronze, silver, gold. Okay. Now, you need always, if you are building a data lake, yeah, you need always a place where you have the raw data as it is. This is very important to not do immediately any transformations. I just want to load. So extract and load the E and the L. I don't want to do anything else, okay? Just the E and the L. I want to put it here in the bronze, and we don't change anything. So it's gonna be usually 1-to-1 copy of the data. Okay. So let me just make this small. This is 1-to-1 copy of the data. I will not do any data transformations. No transformations. Of course, those are my rules, okay? Or let's say the standards as well from Databricks. There is a reference architecture that I'm gonna link it as well in the Notion. You can follow it as well. So we don't do any transformations. We just copy the data as it is, one-to-one inside a bronze. And there's a reason for this, to be honest. Why we do this? The thing is, if something goes wrong on your silver and gold, okay? And I don't know, yeah, you have issues here. Something went wrong. Now, instead of relying on the sources to get the data, you can rely on the bronze in order to have some kind of archive for your data. So with that, you can always rebuild the silver and gold using the bronze without worrying about whether the data is available on the sources. Because in many scenarios, what happens, your source is gonna go and delete the data. They want to optimize their story. They want to do something, yeah? So they go and delete the data. And imagine if you don't have an archive for it, you come to the silver and say, whoa, where is my data? I don't have it. And you're gonna be a big problem. That's why we say we make a bronze layer without any transformations. Because if you do any kind of transformations here, it's gonna be really hard, let's say, to do the transformations backward to get the raw data, okay? So don't touch the data. Don't do any transformations at the first layer. This is gonna save your life in many scenarios during the projects, okay? And it's gonna build an archive for you. And if in your company you have some audits, they're gonna do some audits on the data and stuff like that. You can say, you know what, I have my bronze, go to the bronze and you're gonna see the data. So they can audit the data as well if you have some, I don't know, yeah, security problems, or let's say the source needs some backup. So there is a lot of benefits of having the raw data. So that said, with that, I define my rule. This is the most important thing. You define the rules, okay? Again, now the next step, of course, I need to clean up the data, right? I cannot leave it like this. So that's why you're gonna start doing clean. You're gonna start doing some transformations, but not all of transformations. Transformations, my friends, has always two types, okay? There is transformations that you do in order to clean up the data. Like you're gonna see during the projects, there is transformations where you do a trim for the white spaces, changing the case of the data types, yeah, maybe replacing the nulls with a new value. So there's a lot of cleanup activities that we do. If you learned in SQL, for example, you know all those functions and the string functions, the number functions. So we have a lot of cleanup transformations, I'm gonna call it. But there's another one called business transformations or business rules. It is something that comes from the business and where they say, you know what? If a customer have more than 100 orders, then this customer is VIP. So those rules comes from the business, from the process, from your company. And there is no standards for it. Each company has its own business rules. So this we call as well transformations. Now, since we have two types of transformations, we will not put everything in one place. You know, we always try to split. The more split, the easier to manage. But of course, you have to have a balance. I saw, to be honest, I saw like some projects where they have crazy number of layers. Like I wanted to do a lineage, so I went from one layer to another layer to another layer. So it was crazy how they do the layering, and that's because they have bad data architects. So as well, not for each thing you're gonna go and make like a layer for it. Otherwise, you're gonna lose it. So maximum do 3 layers. And here you're gonna do in the silver only data transform, only cleanup transformations. So you're gonna clean the data, you're gonna do some maybe standards, data type changes. So you define the rules. You know, what is allowed here. And in my projects, to be honest, I didn't allow to do data modeling in the silver layer. There's like, of course, some people are gonna say, oh, this is crazy. Why you don't allow data modeling here? No data modeling. The thing is, I would like to maintain the shape of the data like the source systems. There is, I had it a lot where some data scientist comes and say, hey, I would like to analyze one of the sources, but I would like to have the data as it is. I know the tables, I know the structure. Don't break that model. Don't introduce something new. Yeah, so data scientist or even data analyst or yeah, so DA. So there will be some, like if you work, depends really on how you work, but the bigger the project gets, the more people are gonna come and say, I would like to see the original tables like it is from the sources. But of course in clean way. That's why I made the rule, there is no data modeling in the silver layer, but you can decide something else. You say, yeah, let's go and build a data model inside the silver layer, yeah? But I find it's something that we can do in the next step. Now, in the next step, we're gonna do a gold layer, and here, gonna be the business ready layer, okay? So this is the business layer, where you allow those business rules, yeah? So now you allow to change the shape of the data. You can do like whatever, let's say, go break the data model, go introduce the snowflake, the star schema. Sorry, I just forgot the name. 3 months away from the project and I start forgetting the name. So star schema, build what, even like aggregation, like do whatever you want here, break the model, prepare the data as the final user gonna use it. Okay, so this is the gold layer where you introduce a business. And now you're gonna say the access points for my lake, it's gonna be the silver and the gold. Okay, now many use cases, and I like, by the way, as a data engineer, you have to work as well as not the data owner, but you're going to be the advisor for the data, because data owner are usually from the business. So as a data engineer, you're going to be the product owner. Yeah, exactly, the product owner. So if someone comes like a data analyst or data engineer, say, hey, I would like the data, you can always try to push your gold products because they are really prepared and ready. Yeah, but if things doesn't go work, or let's say doesn't like work for the data analyst or scientist, you say, okay, then you are allowed to go to the silver. But always try to push your final product. So now, once you do these projects, and yeah, let's say you decide, I want to build those 3 layers, and you decide on the rules, then you already have done a lot of things. You made it clear how you're gonna build the Lakehouse. And either you're gonna do it as data engineer or some senior data engineer or data architects. But to be honest, they only do this. They decide on the layering, they decide on the rules, and they write some standards, like maybe some guides for the developers, for the junior data engineers, where you join the project and you check the rules. By the way, if you join any project, always ask about the rules, what you're going to do in each layer, yeah? And if they don't have one, then say, I'm going to create the rules for the project, okay? So this is something that is very important. Now, how are we going to build this? It is, as well, not that crazy. Is simple. Once you understand the pattern, you can build this very easily. So now we have, this is a concept, okay? So this is, we're gonna say high level architecture for your projects. So now how you usually implement this, we write scripts. So you're gonna write a script for the bronze, you're gonna write scripts for the silver, and you're gonna write script for gold. So you have to do some scripting. Okay, so scripting, whether you are using SQL or PySpark, SQL or PySpark, whatever, yeah? So you have to write some kind of scripting. Now, the scripts, they have to do something that is, as I told you with the DataFrame, let me just move those stuff here below. So now, not only scripting, you have to have the storage, right? So you have to build the storage, and usually we put everything in the Unity catalog. Okay, so now what the script gonna do, it's exactly like the data frame. It's just gonna read the data from the left side, do transformations, and then write it to the storage. Then the next script, the silver one, gonna read the data from the previous layer, do transformations. Of course, here we'll not have any transformations at the start, but in the silver, we're going to do transformations, and then you're going to write it back. And then guess what? The last layer, you're going to read from the silver, do transformations, and write back. And that's it. This is all what you have to do in the scripts. Read, do something and write. Now, once the data lands in the final layer, everyone's gonna be happy about it, and you're gonna go and say, hey, the data is ready, go and consume it. Okay. Now, of course, another thing that we have to build is that we have to go and build a data pipeline. This is for the automation. So data pipeline. This is something that we have as well to do in order to make an orchestration. Orchestration means we're gonna put everything in one place, and we're gonna have like a play button. I don't have a play button, so I'm gonna make it like this. I wanna click on this button where it's gonna do the rest. So first, the data pipeline gonna go and trigger. Let me maybe use some laser point. So it's gonna go and trigger this notebook, and then the next step is gonna go trigger this notebook or the script, and then the last step is gonna go trigger this, and that's it. So the data pipeline is a simple thing. It's used for automations, and you can say, you know what, every day, I don't know, yeah, 001 a.m. you have to start. So actually, this is the fundamentals as data engineers. You have to learn how to write scripts. You have to learn how to write into the data, and at the end, how to build a data pipeline. So now, this is the plan, and I want you to do this and to build this kind of projects. Of course, the first thing that you have to do is, my friends, is to go and build or create a repository. Let me just check whether I have it ready here. So now, you have to learn how to work with the Git and GitHub, and it is very simple. You just go and create, first of all, an account in the GitHub, and inside it, you're gonna go and say new, and just make, for example, Databricks, Bootcamp, just give it a name. Okay, so 2026. So you're gonna go and build a new repository or create a new repository because you need it in order to save all your scripts. Okay, but now we will not go in all details on how to use the Git, how to push inside it. We're gonna make just simple repository, and we're gonna store inside it our code, our data sets, and everything. And this is an amazing thing in order as well for you to share at the end your repository. So I would make it as well in the tasks that I expect from you after the bootcamp and stuff, that you build a repository, you put inside it your project, and start sharing it with others, okay? Like in the Discord or maybe in LinkedIn, and you're gonna put inside it everything, yeah? Now, I created already one called Databricks Bootcamp. I say DataCamp the whole time because of the sponsor. I used to say that almost in many videos. So we're gonna get the repository. Okay, so this is my repository. I'm gonna put inside it the code and just copy the URL, from the repository. Now, the first thing that we have to do is to go back to our Databricks, and all our work gonna be now inside the workspaces. So now, again, as a data engineer, you have to keep your eyes on some different stuff in the UI. As a data analyst, we said, okay, the most important thing is for you the SQL, you create the dashboard, the Genie and stuff. But as a data engineer, you have to keep your eye on the workspace, on the catalog, and on the compute. So storage, again, it's like this picture. The scripts, it's the workspace. The storage is the Unity catalog, and the compute. So those three are gonna be your main tools where you have to explore. Now, inside the workspace, you can do a lot of things. You can start writing, I don't know, code and stuff, but we will not do that immediately inside the workspace. We're gonna go and connect our GitHub to the workspace so that I save my work inside my GitHub. Because now if I go and share my work with others, they have to have an account in Databricks. They will not see my code, and you're gonna struggle, or maybe you're gonna lose your account someday. Who knows? Maybe they're gonna stop giving this free edition, but I hope that they will keep doing that. So that means, my friend, work always in a Git folder. So we're gonna go and say create a Git folder. Now I'm gonna go and connect it very easily. So I'm gonna go and give it the URL of the new repository that I have created, and just give it a name. So this is the Bootcamp for data engineering, and then create a folder. So now I am inside now my Git repository, and anything that I do now, it's going to be stored, of course, after I commit inside my Git repository. Now on the left side, let me just guide you a little bit in the UI. There is stuff called home. Okay. If you extend it, you're going to see here the link to the Git. You can see this folder icon called Git folder. That means it is connected with your Git. There is stuff that someone else shared with you. Maybe like I go and share with you a code or something. You can find it over here. And there is stuff that is stored at your workspace. And yeah, so we're going to go inside our Git. And now you can like work here as any like Python project, okay? So you can create folders, you can create Python code or notebooks. So now what I'm going to do, I'm going to say, you know what, I'm going to go and create a new project. So I'm going to call it Spike Lakehouse. Though, yeah, maybe give it a name like this, okay? So here I'm going to put all the codes for my projects. Now inside it, of course, we have two options. So either you're going to work with notebooks or you're going to work with Python files. Now, if it's your first time hearing about the notebooks, let me just go and create a notebook. A notebook, it is like, let's say, an advanced editor where you can use, for example, in Databricks, multiple languages. So I can go and use here a Python, I can use an SQL, an R, Scala. So I can use different programming languages inside my notebook. And I can do it step by step. Like before, if you write a Python code, it's going to be like a huge block of code. And it's going to be really hard to go and execute the subsections of your code. With the notebooks, you can break the complexity into smaller sections. And you can see the result of each step. So for example, here, I'm going to say, for example, I am inside this box. I can do, for example, an SQL query. Okay, so select star from something. Yeah. Now, if I'm done and saw the result, I can start a new block. If you go and hover your mouse here and go and say, you know what, now I would like to work with Python. So I'm going to go and start, the default going to be always Python. So I'm going to start like importing stuff and start writing a for loop and start writing my code. And then after that, you might say, you know what, I would like to put some definitions. So you go and write here, SQL query to explore my tables, for example, like this. So you can start as well documenting the code as a nice document using the markdown language. So this is really amazing way on how to structure or to work with the data. This is originally made for data scientists in order to work, or data analysts as well, to work with the data. And now as well, you can use it as a data engineer. So this is one way on how to write, let's say, code or script in Databricks. But of course, you still can go and write, my friends, a Python code. So not only a notebook. Now, as you go with the project, I will just explain one thing quickly. Now you have those two types of files to write your code. Now I'm going to say at the start, don't write a lot of Python code. Just use notebooks. If you are a junior engineer or you just start your journey with Databricks, try to avoid using Python code. Yeah, because it's going to be a little bit complex for you. I'm going to say work with the notebooks. And once, let's say, you feel yourself comfortable with the tool, with the platform, then start slowly switching to Python files, because it is more professional, let's say, to manage your code and how to call things. So I'm going to say, yeah, at the start, use notebooks and Python, and you're going to end up seeing yourself using both of them. So you're going to write a lot of code using Python. So maybe one for the functions, one for the metadata and stuff like that. And then you're going to end up as well having a notebook that orchestrates those files. Okay. But now this is advanced. This is for later. For now, I'm going to say focus on writing a Python, your code inside a notebook. Now, inside the notebook as well, it's like the SQL query. You're going to find here the server status. Let me just, I think, add my mouse. So you can find the server status, you can start running your notebook, and you can run each section on its own using this play button here. So either run the whole thing, every section, or go and start the whole thing. So, and by the way, this is not something only for Databricks. Notebooks could be used as well in other tools. And the final phase of Vue, let's say, to be honest, long time I didn't work with the notebooks because I switched as well using the Visual Studio Code. Now, the thing is with the Visual Studio Code, it is, let's say, more professional on how to write code, okay? Oh, this is the challenge I made last time. So you can use Visual Studio Code as well to write code inside Databricks, but you have to install an extension, and as well things gonna run locally at your PC in the development time. But I'm gonna say, this is the last step of Vue. Once you write perfect notebooks, once you understand how to work with the UI, start exploring how to use Databricks inside Visual Studio Code, because you're gonna open a lot of features there, and it is more professional to edit the code, to maintain the code, to work with the Git. So I'm gonna say, if you are a junior data engineer, yeah, you're gonna be working inside the UI of Databricks. But if you want to go as a senior, you want to be professional, you have to jump to the next tool, yeah? This is about the scripting, just to give you an intro about it. But let's say at the start, don't overwhelm yourself with a lot of things. I'm just explaining for you how things works in the future, okay? So now, we're gonna do things inside a notebook. And what is very important inside the notebook is to check those three. There are here three icons. They are really, really important. So the last one called the catalog. So once I click on the catalog, I see my data, okay? You see here, you can browse the structure of your data, not the data itself, it's just the structure of your catalog, the tables, the schemas and stuff. So this is something that is important to see. Then you have the workspace structure if you want to browse between the folders. So if I want to navigate through my projects, I'm gonna go over here, click on it, and then start navigating through my projects. If I want to work with the data, then I'm gonna switch to the catalog in order to see the data. So you're gonna see me clicking on those three icons. And the last one, it is amazing to see the structure of my notebook. So for example, maybe I'm gonna go over here and say step 1. This is the step 1. And then I have a sub-step. So I'm gonna say step 1.1. You can see here, I'm getting the structure as well. And then maybe later we're gonna have another one. So step 2. So with that, you can see the structure of your notebook. And of course, this is very important as your code gonna grow and get more complex. It's always to check the table of the content in order to see how the things are structured, and always be structured in how to write your code. I see a lot of junior developers, they jump and start writing code inside the notebooks, and there is no documentations, there is no headers, there is no any table of content. Just take it step by step, organize your notebook, and write always the steps that you are doing, then everything will be easy for you. So now, as you can see, we have those now three things, and this is the notebook structure. Now, I'm gonna say, I want to build this Lakehouse. So, first of all, the first thing that we do actually is that we have to build the storages. So I have to have something called bronze, silver, gold. And now, either you're gonna click around, of course, and create stuff. And of course, you have to decide on the workspace. So I can go and make it inside the workspace, or I can go and create a new completely workspace. If you go and click on the organization, let me just go. Click over here and then create. You can see I can create complete. So I think in the catalog, yeah. So if I go to the catalog, I can create complete new workspace. So it's called here. I don't see it. Maybe in the free edition, I cannot do that anymore. Create catalog, sorry. Create catalog. So if I go over here and say, this is the, I don't know, the dev projects. And with that, you are creating a complete catalog. So as you can see here on the left side, I don't have anymore the workspace. I have as well the dev project. So this is the whole, I can put everything now inside it and start working on it. But now I'm going to stick with the workspace. Now, the first thing is that I want to build the schemas. I want to build all those layers. So what we can do, we're going to go and write script for it, or you can click around where you can say, okay, let's go and create the schemas. I'm going to create first the bronze inside the workspace. So this is the first schema. Then the second one going to be, let me just go back here. So create schema, silver, and then gold. So now this is what we usually do. We put each layer in one schema, and then inside each schema, we're going to find the different tables, okay, that we are processing. So with that, I have empty now containers where I put my data. Of course, I don't have any data yet. Now, in order to make things easy, and this is the thing with the free edition, you cannot go and connect it to, let's say, to your now local database or something like that. I'm going to go now and put my files inside Databricks using a volume. So now what you're going to do, and I'm going to put inside the bronze now a volume. So here, what we're going to do, we're going to put CSV files, and we're going to consider this as a source system. Okay. So this is my, the source system where I'm going to put my CSV files just in order to practice. Okay. So I'm going to go and put now inside the volume, and this is going to be considered as a source system. So I'm going to go to the bronze, make sure to click on the bronze, and then I'm going to go and start saying create volume. I'm going to call it source system just to have it like a real, let's say, projects, source systems, and then create. So as you can see, I'm just preparing the setup now to do the project. So I have now the bronze, and inside it I have a folder. Now again, a volume, it is like a folder in the cloud, and you can put inside it whatever you want. Okay. Now let me just go and grab the data. Let me just see where I've put it. The data that I have. So Databricks. Now, as well, the data is available for you. And if you go to the engineering parts, I created this kind of data that is, let's say, very close to the chaos that you have in projects. Okay. So you have two source systems, the CRM and the ERP. And inside it, you have, let's say, dirty data. They are not really prepared, and they need a lot of transformations to be consumed for analytics. So I have two systems, CRM and ERP, and both of them are storing the files inside CSV. If you've done my SQL projects in data warehousing, you're going to find the same files. So that's why I'm going to use the same thing over here. Now, in order to upload those files, it's going to be very simple. So as we have done it last time, we're going to go and upload this volume. And now all what I have to do is to just drag and drop those files inside this box over here. And then I'm going to say upload. So now with that, as you can see, if I click this away, you can see here, I am inside the volume, and I have here two folders, and inside it, I have my data. So I'm still, let's say, outside my Lakehouse. Okay, we didn't yet load anything. Now, what we said about the bronze, guys, we said in the bronze, we're gonna take the data as it is, and we will just load it inside the bronze. Okay, so, and that, of course, once we load the data inside, we will be using all time delta tables. Let me just take this icon here. So the storage of all those layers, it's going to be delta tables. We will not, let's say, save CSV files as a data to be used. Okay, so we have to convert everything to a delta table. So this is the format that we're going to use. And now the source systems, of course, we have here CSV files. Now, how are we going to start writing the code? For this, we're going to go, of course, to the workspace, and I'm going to go inside my projects. And now I'm going to go inside folder that I just created. So now I still don't have anything yet. It's just one notebook. I'm going to go inside it and I'm going to go give it a name. So this is going to be the bronze layer. Bronze. Yeah. Take it. Bronze. And I will just delete those stuff. Just to start from the scratch. So now. Okay. So now what we have to do is again to load, as I told you, over here. So we're going to load the data from the volume, then do nothing to it. We'll not do any data transformations and load it back to the bronze. So it's pretty simple, right? So read and write. Now we're going to go over here and start saying, for example, let's go and write code. So we're going to say, we're going to go and create a data frame where we're going to read the data from the CSV file, right? So we're going to say Spark. Now I'm writing Spark code. I'm going to say read. And then here we're going to have different options on how to read the CSV files. So we're going to say the header. And then if I remember exactly, we're going to say, okay, they contain header. So true. So as you can see, now we start scripting, right? So we start writing code. So the Spark first option is I'm going to read the file with the header, and then I'm going to say I want to use the same schema. So infer schema, and then true. And then now it's suggesting for me the rest, of course. So it's going to be CSV, and I will put everything here inside CSV file. Just a second. So we're going to say item, and then inside the item, I think we're going to put the CSV file. So the path going to be the path of the file. I have to check. So now it's going to be the volume. So the volumes, workspace, bronze, raw files. We're going to call it, I think, not from the bronze, where we have that data. Just a second, let me check here. So it is in the source systems. Ah, yeah, here. So just have to find the correct place. So it's going to be in the bronze and then the source CRM. And then where it is, it's going to be the cost info.csv. So I am here. Okay, so I am reading now the CSV file, let's say. And now, since we said in the bronze layer, we don't want to do any data transformations, we're going to do and write it directly to the goal. And the goal here is, of course, is the bronze. Okay, so we read, we put it in DataFrame, and then we write it. And this is, again, this is our goal. So now, as well, same thing. I'm going to say maybe here in the text, reading from CSV file as documentation. Now the next step, we're going to say write it to bronze layer. Okay, so we're going to write the whole thing inside the bronze layer, and for that we're going to use as well the data frame, and here we're going to write it like this. So we're going to say df write, and then mode. Yeah, as you can see, I'm getting the suggestion. I'm going to follow it. So we're going to write, and of course you have to define always how you're going to write the data, whether it is an overwrite, an insert, or an update. So doesn't matter. Let's say the thing that you define. And I'm going to define here now the goal. The goal is going to be the bronze dots, and now I'm going to give it a name. It's going to be maybe the same name as it gets from the source system, but I'm going to give it first the source system. It's going to be CRM underscore cost info, and that's it. So now with this, let me just try this out, whether it works. So now with this, I'm writing the data frame that I collected inside the new table, inside the schema bronze CRM cost info. So now it is done. And now, of course, we have to go and check. So we're going to write SQL maybe for it and go to the catalog. And then we're going to go to the workspace, bronze. And it actually should be here. So I think it went to the default, right? No. I have to use the catalog. Yeah. So I'm gonna say it must be go to the workspace. I have to find always the how to call it, the catalog where it goes. So workspace bronze. Let's just try it again. So it must go there. Okay. Let me just try to select the data. So select from this table. Look, it is now inside. Maybe I'm gonna go and refresh. Ah, look at this. It is here. So now, if you look inside the schema bronze, I just written the data frame inside the table. And now I have a table called CRM cost info. And the data is stored as, let's say it is a delta file now, a delta table. Now, if I go to my catalog on the left side, of course, and go browse the schema, I will see now I have just converted the volume, the CSV file, into a table. So with that, I can see that the data is loaded one-to-one inside the bronze, and it is now using, let's say, the new technology, the delta tables, and actually that's all what we do in the bronze layer. We just load the data as it is, one-to-one from the sources inside our table. So now what we're gonna do actually is that we have to go and repeat the same thing for each file, for each table, in order to create the bronze layer. So now if I go to the bronze layer over here, you see in the volumes, I have like, let's say 6 files, and I have to go and repeat the same thing like 6 times. Now here, of course, as you are writing your first script inside your Lakehouse, the first time you're gonna be writing it like this. You know what? I'm doing all the thing for one table. Now, once you write it inside this, inside this notebook, you have to review the whole thing and think about it, how to make things more smarter. Like, for example, I can go and put the whole path, for example, in a dictionary in order to do iterations, because I'm repeating the same thing now over and over. So now you're going to find yourself doing the same steps over and over for each table. And of course, this is something not really nice to do. But now just for the test, we're going to go and grab, let's say, the next file. And it's going to be this one here. So this time I will not make mistakes. Hopefully, of course. So we're going to read the file and then write it. Yeah. So let's see whether I have done any mistakes here. So just copy again, check. I'll just change here the CSV file name. So brd info, and then store it again in the next file. Okay. So brd info. So actually that's it. If I go and execute it, so now I moved the data from the volume to the bronze. So if I go and refresh, check the workspace, bronze, tables, you can see I have now my second table. So now, thing is, I'm gonna go and keep repeating this step, okay? Because this is something that we have to do for all files. Imagine you have to do this for thousands of files, right? So that's why it will not be really smart to keep repeating and repeating and repeating. What we do in this case, in engineering parts, to not have the same things over and over, we go and make like some kind of metadata, or let's say configuration. And I have here, as I was today preparing it, you go and create and put all the path of the files in a separate config file. We call it config file. And here inside this Python code, there is no, let's say, there is no anything about Python code, or we are not doing any transformations or loading. We are just describing the parameters of the files. So I'm going to say, okay, for example, I have the source system CRM, then the next one is going to be the path of the file, and then the target. So now I just describe it like the source, the target, and the path, and I describe this for each file. So with that, I'm going to have my, let's say, my configurations, and then in the bronze, and the next step in the notebook, I will just do a very simple iterations. So now what I'm going to do, I'm just going to go and read my configurations, and then I will just do a very simple for loop. So I'm going to go loop through all the configurations that I have done. And then as you can see here, I'm reading from the file and I'm writing to the file, to the Delta table. So with that, I will not go and repeat, or let's say copy paste the code like 200 times. I'm going to be configuring it and then looping through the files. And this is something that's always going to be like this. So you always start writing from the scratch at the first tables, and then over the time you're going to see, I'm repeating myself, and then you're going to start doing some for loops and make it more smarter. So now, of course, I can go and it's going to work. Now, if I go and start like doing the same thing over and over, this is going to work, but it will not be nice, because if you decided to change, let's say, for example, I decided to change the mode. It's not anymore overwrite. I would like to make an upsert or merge or something. Then I have to go for each table and change it, right? But if you have your code, let's say, like this, I just have to change it in one place, and then this is going to be iterated for the rest of the files. So this is the next step that we usually do. We look to what we have done, and then we try to make it smarter. So now, if you look to the notebook, you're going to find to the structure, you can find it is very simple. We are just reading from the source and writing in the bronze layer. And you're going to repeat doing this for all the files. So I will say that's all for the bronze. And if we go to the next level, where you say, we're going to build the silver, okay? So the silver, it's all about reading from the bronze and now writing in the silver. But in the way, we have to do some transformations, right? As we said, we have to do cleanup for the data, we have to do some standard stuff, and to make changing of the data type, but we will not change the data module. So if I go back to my workspace here, I'm going to go and create a new notebook. And this time, I'm going to call it maybe silver, but for the first table. So if I have here, let me just go back to the catalog. What do we have here? In the bronze tables. So now I'm going to say, okay, I'm going to go and start preparing the first table from the bronze. So what is the first table? It is the CRM cost info. Now, how going to be the structure of this notebook? It's going to be 3 steps. So the first step is going to be, of course, reading, right? So we have to read from a bronze. We have to do then, this is how I like structure first my code. I'm going to say then I'm going to do some data transformations. Yeah. And then the last step, I'm going to write back, I'll write into silver table. So this is the basic, let's say, structure of your notebook. In the silver, you read the data, you do data transformation, and then what you're gonna do, you're gonna write it. So now, let me just check. Okay, so now just to make things a little bit faster, I will try to get the code that I have prepared today, so that I don't have to write things from the scratch and make mistakes on the way. So just give me a second. So the code, demo, code, silver. So now, okay, now the first thing that you have to do, as I said, is to read from the bronze table. And this time it's going to be easier because I don't have to deal with the CSVs and stuff. I'm just reading from a delta table. So the first thing is that we create a data frame, and we're going to say Spark table. And then I'm going to specify the table that I want to prepare, right? So it's going to be the customer info. So with that, if I run it, I'm creating now the data frame. Okay, so I'm back to this picture again. Yeah, here. So now I'm reading from the source, which is the bronze. I'm putting now in data frame. And now the data is inside the data frame. I would, as you can see here, PySpark SQL connect data frame. I created one. And now I'm going to do something about this data frame, right? I have to do like preparations. Now, in order to understand what to prepare, you have to explore the data. You have to analyze the data. What are the issues inside this file? So that's why actually we usually do as a next step before we do any transformations, you explore the data and find issues. So I'm going to go and say, okay, df display and start exploring the content of this file. What is the quality? Now, of course, maybe from the symbol of data, you can understand few stuff. Like, for example, if I check here, I'm going to see the names of the table is not friendly. As you can see, the names are not really friendly. I have to maybe rename it. This is as well one type of transformations or cleanup. So I can rename the table column names and as well the table names if they are not friendly. I can check, for example, as you can see here, it says the order, so I think it is reading the order of data. Let me check. I think I as well. We loaded the wrong data inside this table. Okay, we have the order information now inside the customers, which is not really good. So as you can see, I have made as well mistakes in the bronze. Let me see what I have done here. So we are reading from this is not correct. So I have read from the sales details and written inside the customer's info, which is not really nice. So I'm gonna maybe change it in the bronze. So I'm gonna read from the correct one and then write in the correct one. Okay, so this is the same file, same table. Let me just run this again. Does not exist. Yeah, because of this SRM at the start. So checked. So now I think we're gonna get the correct data. I have to drop the table first. Oh yes. So merge schema. I would say I'm gonna drop the table. I don't like it. So drop table SQL. Help me here. Drop table, and I will drop the whole thing. So it's gonna be this one here. Drop table workspace dot bronze dot CRM customer table. So it is dropped, and now we should not get an error. Reject and run. Okay, so now back to the silver. And I'm gonna rerun my data frame. So I'm gonna read the new data, and then let's check the display. Now I'm getting the customer info. So correct. So now this is one of the issues that I noticed. So as you can see as well, the column names are not correct. Now, if you check over here, you can see, for example, there are white spaces inside the data. Like for example, here the first name has some white spaces by just looking at the data. So the string values are not clean. We have to trim the data. This is very important. This is the one very famous mistake that you can get, is that the data should be trimmed, yeah, for the string values. And as well, now there is different ways on how to transform the data. Like for example, here I have those shortcuts, yeah, or abbreviations of the status or the gender. Now I can decide as well in my project to say I'm gonna get a full friendly names or values for my data. So depends on what you collect as you are exploring the data. Like for example, here I already saw that I have to trim the string values. I have to make normalizations for the marital status and the gender. So I'm just collecting the issues by just checking the data, or you can start querying the data, for example, for the nulls. And I can say the names are not friendly for both the table and as well the column. So you start exploring, you know, what are the issues that you can find inside the bronze table. You check as well the data types. Like for example, here the date. I can see this date is okay. So the format is correct. There is no strange things. And with that, you collect the thing that you have to transform and you start doing the transformations. Like for example, I'm going to make a rule where in my projects, I'm going to go and trim always the spaces in all string values. Whether there is space or not, I will just make sure that there are no spaces. So for example, I'm going to go and make a for loop. So for fields. So for fields in df schema fields. And with that, you're going to go and iterate through all the columns inside the data frame. And here I'm going to say if is instance, for example, if the data type, as you can see, now I'm getting the whole suggestion. So if the data type is a string, if the column is a string value, you have to do something about it. So I will not do replace. I'm going to go and say df with column. And now I'm using PySpark operations, okay? So field name, and then trim. I want to trim the columns of the field name. So with that, I hope that I got the syntax correct. So with that, I'm saying go through the whole data frame, column by column, and check the data type. If the data type is string, then go and apply the trim on top of it. So with that, I make sure that all the string values are trimmed and I should not face any issues with that. But of course, I think I have to import some libraries. So I'm going to go first and do, this is usually what we do at the start. We start importing some PySpark functions and let's say modules in order to do the data transformations. Like for example, here, the column, the trim, the string types, all of those stuffs are stuff that I have to import in Python. So that's why the first step is going to be always going to be the init step. So I'm just going to say this is md. And this is going to be the init step. And with that, if I go and run it, I'm importing the things and now we should not get any issues. So let's run it again. And it is working. So now if I go and display it again, df display, as you can see, with that, all the string values are corrected. I don't have any white spaces on the left or on the right, and this can happen for all the string values. So I can say successfully, we'll just go and remove this one here. So successfully, we have done the first data transformations, and this one called trimming the values. So this is one thing. And another thing that we can do is that we start giving some, let me just display the data frame again. So df display. You start fixing the issues step by step for each table. So with that, we fixed one of the issues. Another issue, as I said, those are abbreviations. I would like to have the full name of those abbreviations. So I'm going to go and do some kind of, let's say, normalizations, yeah, of the code. The data, sorry. So we make from the abbreviations a longer name. So this is a second step in my transformations. I have the code here prepared, so I don't have to write the whole thing. So what I'm saying here, if you find an S, then make it single. If an M, married. If an F, then female. If an M, male. So I'm just making things more friendly. And it is just a case when, of course, I'm using now the PySpark. You can go, of course, and start using an SQL, the case statement of the SQL. So I don't have to, let's say, start writing those PySpark operations. I can go and do the whole thing using SQL, where we're gonna say, you know, you remember select, and then case when, and then end, from, stuff like that. So you can do the whole thing using SQL, the data transformations. It's not only PySpark, but I would like to show you just the PySpark. It is as well very simple. You just know the syntax. So it is as well when it is equal to s, then replace it with single and married and stuff like that. So it's just all about to understand the syntax. And if I go and, for example, execute this part, I will be as well now normalizing the names. So now if I go over here and say, show me the data, you can see now I have the full names for those columns. So with that, I have done another type of data cleanup. I'm making things more usable, easier to use, and understandable. Now, the last thing is that I would like to go and rename the columns. So as you can see here, CTEID, first name, there is like those cryptical prefixes at the start, GNDR. Like I would like to have a very simple naming convention for it. And of course, you have to decide in the project how you're going to do the naming, whether it's going to be an English or different language. So now as well, renaming considered to be a data transformation. So now what I'm going to say, I'm going to go and how we usually do it is that you will not go one by one renaming the columns by operations. We usually define at the start the schema, or let's say how things can be mapped. And here I'm using a dictionary now. So now I'm saying if it is CTE ID, then it's going to be the customer ID. I'm doing some kind of mapping or translations. Okay. So I'm just going to put it in a dictionary where I define the column names. And of course, if you want to be more advanced on this, you can go and start specifying in the dictionary a lot of things like the data type, the comment, the description of the columns. So you can add a lot of things inside it, not only the translation, but for now I'm going to make it simple. So I'm just mapping the names from the old to the new. And now we're going to do the step over here where I'm going to say renaming the columns. So if I go now, there's a code snippet for it where I prepared it. So we're going to go and iterate through all the columns inside this dictionary. And we're going to start replacing the old name with a new name. So I'm just renaming things in one simple for loop. So let me just check this. I think I have a different name for this. I have to execute the first parts. So let me just execute this. It's not yet defined. So try and okay, and then run this here. Okay, so perfect. Now I'm going to display again. Always check each step by step you do. Always check what happens to your data frame. So now look at this. I have now friendly names. The values are correct. The values of the status, the gender, I have long names. So with that, I have done 3 transformations in this data frame. So again, by looking at this, if you think about it, we have here a bronze table. Let me just remove this here. So we have bronze table. The target is a silver table. So, and we went through 3 stages in this code. So first we read the data inside data frame, and then I have done the trim. So we have done here a trim. Now it went the data frame to the second stage where we said, you know what, do the normalization for the data frame. And then, of course, the last step, I just renamed the data frame. So rename. Now I'm done. Let's say we are done with the transformations. Those are the 3 steps. Now the last thing, I'm just go and write it to the silver. So it's going to be the same command. It's not something crazy. Let me just grab this here. So I don't need to display the data anymore. I am at the final stage, and now I'm going to go and write it to a silver. Now, each time you want to write thing, always you have to decide the mode. Now, as I told you, the easiest mode for small data is always overwrite. So that means I'm replacing the whole table. I'm removing all data and inserting new data. So now, if I go and execute it, it will be now loading the data in the gold table. Of course, we have always to check whether it is written correctly, not to make mistakes like I have done. So if I go to the workspace over here and go to the silver, I can find my table. So now, of course, I can go and query the data from the silver. Of course, I have to switch to SQL, select star from, then I will see the cleaned up data inside my notebook. Now, of course, it is always nice to see when you are done the structure. So look at this. At the start, I just imported a few things from PySpark and I mapped, let's say, the friendly values of the columns. So this is the initialization step. Then I read from the prompts, I do the transformations, trimming, normalization, renaming the columns, and at the end, just write it back somewhere in the silver. So actually, that's it for the silver table. And of course, if I want to extend this, we can go through all files, but it's going to be taking a lot of time. So if I go to the prompts, we have to go and, of course, to do all those stuff for each table. So as you can see, this is something that is really involves a lot of manual work. And imagine you have like thousands of tables. In my project, we have 800 tables, and that's why we spent around, I can tell you, 3-4 years just preparing the data. So that's why I'm gonna explain for you. It's still a lot of work that has to be done from data engineers. Now, things gonna work like this. If I have here from the sources, I have, let's say, 1000 table. You will not be able, let's say, to clean up everything in one go. You have to spend always to decide which are the most important tables and stuff. So maybe if you are good enough, you cleaned up only 500 tables. So usually in the silver, we can have like half the amount or not everything cleaned up. It needs time. And in the gold, of course, you will not go and module everything from the start and stuff. So in the gold, you might end up having from the 500, you're gonna by doing some joins and stuff, maybe maximum 50 tables. So this is because it is very hard to go from one stage to another stage. Okay. But I'm gonna say, 50 tables, but after joining a lot of tables and stuff. So with that, I'm saying whatever you get from the sources doesn't mean that you can process everything until the gold. Okay. So sometimes you process only the tables that you really need, and depends on the team of that in the projects. You're gonna end up cleaning a lot of things. We had 12 data engineers. That's why we managed to clean up 500 tables. And this something, of course, AI cannot do that for us. Now, as you can see, it is taking some time just cleaning up few tables. They are simple tables I'm having in the demo, but as you can see, it's taking time. And imagine now you have a lot of data, a lot of tables. You have to understand the content, the complexity, and start doing transformations. That's why the AI, for example, here is only assisting me with the syntax, because I will not memorize all the syntaxes of the PySpark, of course. So AI gonna speed up the process so that if I make mistakes, it's gonna assist me. But you will not have an AI for now that's gonna do the whole thing for you. It will not work. It will never, it might happen, but for now, you need data engineers to do this. So as you can see, it is already a lot of work that you are doing. AI gonna assist us in building, let's say, the syntax, helping us in the syntax and stuff, but it will not write this. You will always need, for now, human to do those corrections. And those stuff were easy, but in real projects, if you go in a difficult domain, the cleanup process might take a lot of time. So now, again, what you have done, we have done this for first table. And yeah, if we go to the code that I have prepared over here, I went through all the tables and done the same thing. So again, for example, the next table, I'm going to go and start translating things from one table, from one column to another. I read the table from the bronze, do transformations, depend on the content of the data, and then write it back. So I went and done it for all tables that I have prepared for you, but it's something that you have to do on your own. So you will have a template as a reference for you, but I really recommend you to do the same what I'm doing now. Read the data inside DataFrame, explore it, and think about what is wrong, how to correct it, and then write it back at the end to the next layer. Now, I just wanted to show you one example. Of course, the next stage is the same thing, right? We want to write a gold layer. So now, what we're going to do, we're going to read from the silver, apply some transformations, I write it back to the gold layer, okay? Now, let me check whether we can do this quickly, because I think we have already 3 hours. Now, I'm going to go over our workspace again. So what do we have inside the project? We have the bronze scripts. We have the silver only for one table. Of course, they are not complete. And now we're going to go and create one more for the gold. And of course, you're going to make one notebook for each table. Okay? I will not put everything in one notebook. So it's going to be one gold for example, the customers. Just let me check. So go there. Okay. So now, the gold layer from coding perspective is going to be the easiest compared to the silver or bronze. But it has one complication, that you have to understand how to do the business transformations and how to do the data modeling. Because the thing is, as you can see in the silver, I didn't change the data model. It was one table, I written it in one table. I didn't change it or something like that. But in the business, or let's say in the gold layer, I have to introduce a new model. And here the complexity is all about the data modeling. How I'm gonna, let's say, present the data. There are different ways on how to model data. So this is of course a big section about data modeling. Like you have star schema. Let me just show you here. Maybe you have some nice pictures about it. I have, of course, explained those stuff in the SQL course. So you're going to have like some central table called facts, and then you're going to design rounded dimensions. So, and this is something that you have to do in the gold layer. You have to decide on how to model the data inside your gold layer. So either use fact and dimensions. Some other people goes in another direction where they say, you know what, I will not go in this complexity of making dimensions and facts. I'm going to go and make something called flat tables. Flat tables means I'm going to go and make a very huge table where, so let me just have here an example for you. Do I have here a table? Yeah, so either you say, you know what, I'm going to go and make fact and dimensions. And as we saw in the picture, so this is dimensions, dimension here, dimension. So, and here are facts. And you start building this model, which is very perfect for business intelligence, of course. This is amazing for business intelligence and Power BI. If you give Power BI this model, it's going to be very happy. And the data analyst can immediately do amazing things. So, and this is what I recommend you as well to build, is to build dimensional data model. Some lazy people, let's say, they don't do that because it is complex. Or let's say they don't have the skills to do this. So what they do, they make one big flat table, yeah? So they're gonna put all the information that they need for the analysis in one big table. Of course, this is gonna be a huge table if you do that. Like for example, in our data, in our example, we have 6 files. You can actually go and put everything in one big table. Yeah, and then you say, you know what, go and connect your Power BI to this one big flat table. So this is of course something you can do, but I find it lazy and not interesting to module. You have to do proper data modeling. So you have to build dimensions and facts in order to make things easier, let's say, first of all, for the BI. And it is easier to do a lot of operations in the BI world where you do, for example, the aggregations, the slicing, the filtering on the dimensions and stuff. I'm not going into those details because it takes a lot of time. Let's explain it. But what I'm saying, you have to decide how you're going to present the data. So if I decided to make it as a star schema, then I have to commit on that. And I have to start modeling the data that looks like star schema and then start building the gold layer for that. And if you say, no, I would like to make it flat tables, then just make the rule here. We make flat tables. And maybe you can go and decide on both of them. You say, I'm going to make flat tables and as well star schema. Yeah. So you have to decide on how you're going to build the gold and how the shape of this kind of looks like. In the example that I prepared for you, I'm going to build a star schema, but I will not be able now to show the code, to be honest, because I am a little bit, let's say, tired. That's why what I'm going to say, the structure of the gold notebook, it looks exactly like this. So again, we have initial step. This is the first. It's like the silver. I need to read. So again, where we're going to read from? So we're going to read from silver table or tables if you want to merge multiple tables together. Okay, so table or tables, depends. Then you're going to do, I'm going to say the business transformation and modeling. Okay, and then after that, the last step in your notebook, you're going to go and write it to the gold table. Yeah, something like that. And if you go to the silver, it looks exactly the same steps, yeah? But the source is different, the target is different, and the type of transformations is different. Now, I should not, in the gold layer, I should not go and do trimming or do, let's say, casting of data types. If I do it in the gold, then this is a mistake, because I haven't done it in the previous layer. So make sure, and this happens a lot. If I'm working with the gold, I notice, the data's still dirty. I go back to the silver and start cleaning up and then go back again to the gold and start doing the gold transformations. So now I'm going to show you just an example how this kind of looks like. Do I have here? So the initial steps, it's going to be the same things. So you're going to go and read from PySpark modules and prepare things. And now comes the very important part, is how to do the data transformation. Now, this is something that I discussed a lot in my team. Okay. Now, why I tend always to use SQL? There's a reason. So in my team, we had this struggle. Some people says, you know what, I want to work with the PySpark. I just want to work using Python and those stuff. And there is another group of people, they said, you know what, SQL is way better to do this. Now, why I prefer to write only SQL in the gold layer, and that's because the logic comes from the business. And believe me, showing the code for the business from PySpark, no one gonna understand it, because once, this is the struggle as a data engineer. Okay, again, so let me grab the business people or maybe the data analyst or someone. Let me grab this one, this guy here. It's data engineer. So data analyst, maybe data analyst. A lot of people can be involved in the code layer, how to do the business transformations. So business users, I have to just to check whether I'm still on the stream, because to be honest, oh, I'm still on stream, right? I didn't check at all. Sorry for that. Are you guys understanding what I'm trying to say? Are you guys confused? Now, yes, for 1 week. Please show example of flips. Okay, I'm gonna continue. Okay, I hope that I didn't lose you guys. Ah, the music background still playing. Oh my god. Wow. Really? My god, I really apologize for this. I promise you I'm gonna go and make another bootcamp. I apologize a lot. I didn't prepare a lot because, to be honest, it's my first bootcamp that I do, and I decided it's time to not prepare. I just wanted to go and talk to you about how we do the projects, to be natural, you know. I don't want to have scripted, let's say, bootcamp, or to have presentations and stuff. So I just I just wanted to go through the projects, and yeah, sometimes we struggle like this if you forget about the syntax and stuff. But you like the music, guys? Okay. Maybe the music was the best part. Well, you have to play in Black Soul, guys. Okay, I'm gonna put slowly the music. How many people we have still here? I cannot imagine that we have a lot of people still here. I'm pretty sure I'm lost like most of you. Let me check. 1K, 1,000 people are still watching. What are you doing, guys, here? I just... The background music was great. Sorry, I just want to drink some water, and I'm gonna get back to you because I'm a little bit tired. I'm talking for 2 hours now. I love you all, and I'm happy that you're enjoying it. Okay. No, please, not the music. Okay. So I don't know. Yeah? Some of you need the music, some not. I'm gonna remove the music because it's distracting. 1 minute, and I'm gonna be here just to drink some water. The thing is, guys, I talked to one of my friends as a data engineer, and I told him, you know what? I'm gonna explain a data lakehouse live stream, and he's told me, no way you can do this because it takes a lot of time, and yeah, it's something that you need maybe a week to build. And of course, I wanted this to be like a little bit challenge for me to say, no, I can press everything in one. I'm gonna explain from the data engineering step until we build a lakehouse. I'm gonna do the whole thing in one session. So I think it was a little bit hard, especially if you're not prepared at all. I just prepared the Notion roadmap and the little bit the sketches, what I'm gonna sketch for you, but the code, I just played with it today. So you know what, I was not really ready for it, but I hope that you are enjoying it, and I'm enjoying it as well. It's a challenge for me. First time I do such a live stream, because usually I hide, like, let's say I do it behind the screen. I take my time, record, edit and stuff. But doing it live, it's going to be challenging because there's a lot of ideas. And always I have to keep in my mind that some of you guys are juniors. Maybe some of you first time hearing about those stuff. So I have to keep this in my mind and not to explain things as I'm explaining it for an expert. So I hope that you are enjoying it, and yeah. So, okay, so you guys are still here. I thought no one is here anymore, but we have 1,000 people here. Guys, if you like it, just share it and support the channel, okay? Be nice and support the channel, and I see the love. Thank you so much. So I'm gonna put the chats here. I promise I'm gonna improve on those bootcamps and, let's say, on the live chat and interact to you more. My coffee is here. I drank my last coffee. But the thing is, it's too late. It's late for more coffee. It's only in the morning. I usually after 2 o'clock I don't drink any more coffee. Otherwise, I'm gonna sleep bad. So I'm gonna get back to you after we are done the final step. So let's keep going. Now, the code layer. It is something that's I'm gonna say. It is something that is hard to build because of the business rules, and this is something that makes Lakehouse hard for data engineers because we have to understand the business. And as I told you, if I have 1,000 table, like how the hell I'm gonna understand all of them? And as a project lead, to be honest, I struggled a lot with this because the department, or let's say the company, gonna push on you. If you have a nice solution building Lakehouse, I started my projects with only 8 tables, and we were only 2 persons on the projects in Mercedes-Benz. And I managed to make 2 tables here and here 5 tables. So this is my start 5 years ago. And then once things worked and the first data analysts start working on this gold layer, things start to scale. So I start getting one system after another. And I start as well leading this and telling, okay, you know what, I need one more data engineer because more sources, more data. So we start to have like 100 tables, here 20, and maybe here 5 or let's say 10, yeah? And the more I get sources, I stacked more people until I reached like a cap where my department say, you cannot hire more people on your projects. That's it, 20. And of course, not all of them were data engineers, but some of them were data analysts from business. So we were like mixed people and some data scientists. And we reached at the ends of the project like 1,000 tables. And yeah, the 500. And here, I can't recall, maybe 80 or something like that. Now, of course, you're going to ask how those 20 people understood thousands of tables. Well, first of all, time. You're going to learn with the time about the domain. I know a lot of things about the domain that I learned. I worked with because of those transformations, because of those layers, okay? So only through the project, you're going to learn how to do the transformations, how to build the model. So it's need time. And since I have the hard cap of my projects, only 20 people, that's why I am forced to do a lot of, let's say, optimizations in the code on how we structure the code. So we worked a lot on building. Let me just grab this again. This is the main idea of making things automated. We worked a lot on making a perfect metadata, config files, and our main jobs, it was all about making a for loop. It's only looping through the metadata. So the scripts in my project was very small. We don't have like big codes. And that's because of the help of the automation that we do of working on the metadata. We always describe the data first and then write the code. So I describe always what is the source, where the path, what is the target, and then we go and iterate through all the columns and the tables. And now I'm just doing for you one example project. I'm going to give you the code, of course, that's so that you have it. But I'm planning for this year as well to go fully in one project that maybe takes a month or something, like for really give it enough time. Either I'm going to record it or doing it live like this. But I want really to go deeper on how to build fully automated Lakehouse like an expert, okay, like top level. So I'm showing now only like for a junior level how to build a Lakehouse. But if things get real, you're going to get a lot of tables and you have to do some kind of automations. So now back to the topic, to the gold layer. And here there is a dilemma about this where I was in the lead and I have engineers telling me, let's go and write things in the PySpark. And others says, let's go write things in the SQL. Now, of course, if you use PySpark, it is, let's say, looks more advanced, but I noticed something that we always gonna ask the opinion of the experts, whether it's a data analyst or maybe a process expert. You know, I grab someone from the process experts that knows about the cars in Mercedes-Benz more than me and tell him, hey, come, please help me about the data. I'm not understanding anything. They join the project, not join the project. We go in a meeting and stuff. And then I explain for him the code layer, like show him the code and show him the stuff. And once I show people the PySpark code, I lose them. They will never understand what I'm talking about because they are not used to see Python code. Okay. So that's why I decided in my project to use only SQL on the code layer, because it involves a lot of discussion with a business, non-technical people. I'm not saying that unless it's not technical. You guys maybe learn some Python. But since I'm discussing this a lot with the end user or with the consumers of my data, I decided to use only SQL in my code layer. But of course, there is no wrong and right. You can use both, and depends on the team. Some people really, some high-end data engineers, they hate writing SQL. I don't know why. I like writing it, but I like simplifying things. But there are some people, they are scripters. They just script things in Python like crazy, and they use only PySpark. So I made a rule only SQL in the code layer. And yeah, and this makes easier. And over the time, I noticed as well, I had more people helping me and building the model. And this was a nice thing. So that's why I recommend you to use PySpark maybe and in the silver layer, but with the gold layer, go fully SQL. And that's why I wanted to show you the code. Dun, dun, dun. So the gold layer. So it's gonna look like this. I'll just go and grab the logic. Of course, I didn't prepare all the silver tables. That's why it will not work. But now you're gonna write an SQL query. So as you can see, this is the flexibility now with the notebook. In one place, you write SQL, then Python, then jump back to SQL. So we're gonna write the logic only using SQL. So for example, here, I'm building the customer key. I'm having another case when I'm joining the tables. Of course, you can do the whole thing using PySpark, but I'm joining the tables and I'm preparing, let's say, the logic. Of course, here there's not a big logic for the business users, but I think I have another better example. Let me just check. SQL warehouse, docs, scripts called. I'm just trying to find you one business logic that you can maybe understand me. It's the reports. So yeah, I don't have the code ready. So it's all about actually business logic. It's all about defining the rules. Like for example, I'm just gonna give an example. For example, if the total number of orders, let's say, yeah, if the sum of orders, of course it's not prepared now, but if the total number of orders, as I said, like over 100, then this is green. Yeah, if it is lower, then as you can see here, I'm getting the suggestion like crazy from the AI. If it is lower than yellow, otherwise it is red. So I'm defining here the loyalty of the customers. This is a business rule. This is something that I will never know from my own. I have to ask someone from the process when it is critical, or when how we're gonna rank the customers and stuff like that. So as you can see, it is just simple SQL statements. That's where you're gonna define the business rules, and you're gonna build the model that you want. So as you can see here, I'm joining multiple tables and I'm building only one table about the customers. Now, in our silver, if you go through the files, you're gonna find like we have 3 tables about the customers. So we have the customers info, we have another table about the customers for the locations, maybe about the, what do we have? The emails or stuff like that. So the customer's informations are spreaded multiple ways, and I decided in the gold layer that I'm gonna go and put everything in one dimension called the customer's dimension. So I'm changing now the shape. In the silver, it was one table inside, getting inside, transforming the table, and then writing one table. So it's only one table in, one table out. But with the gold layer, I can go and merge like 5, 6 tables in one big flat table, or building the dimension that involves multiple tables from the sources. So it's gonna look like this. You're gonna write a query. Let me just go back. So good. Just jump to another projects. So okay. And actually, you're gonna run this query inside the Spark to put it in DataFrame. So now, of course, I don't have all the tables. I have only the customer's info. That's why I will not be able to join all those tables. I'm gonna go and remove them. But the whole notebook is gonna be ready for you once you start working. Let's say it's something like this, okay? It's just select from and then row number. It's not crazy things. But imagine there is joins, and I'm building now the dimension. Customers, so it's going to be dim customers, and with that I'm putting now the data inside a data frame. It says here something wrong, so I don't have this table anymore. Check, do we have a silver here? Did I run the silver? So silver. I called it customers info, so I renamed the table. So customer info, customers, like this, then run. And what else? So I think I have to check, rename stuff. So customer ID, customer name, number. We don't have customer number. We have customer key. So first name, last name, whatever, yeah. So run again. Okay. So with that, I consider to be, let's say, the business transformation. Actually, it must be here. So there is no reading actually from silver tables. Going to be automatically done inside the from, right? Because we are using SQL. So I'm reading from the silver. It is inside the query, and I put it in DataFrame. At other ends, guess what? We're going to go and write it in a gold table. We're going to call this the dimension customers. Now, of course, the customer key doesn't exist. We have 2 customers keys, sorry. Let's go and remove it and then run again. Thank you. Just got my tea. So now, and then I'm gonna write it back to the gold dialog, customers. Let's go to the catalog now, to the workspace, to the gold. And with that, as you can see, I have the dimension customers. So actually, as you can see, the gold layer, it's something that is easy to implement. This is the easiest one. You can see I'm just writing an SQL, putting it in DataFrame, and then writing it back to the gold layer. But the magic, of course, is all about how to design the gold layer, how to write the business logic. And if you follow now my scripts, where we're going to go and create a dimension for the customers, a dimension for the products, and the fact table for the sales. I'm going to put for you, let's say, the guide step by step on the tasks and how to do it. But I just wanted you to show you an example on how we do things over here. So again, let me just recap. The bronze layer, it was simple. We read the data from whatever it comes from CSV. We write it back. It's not a big deal. It is as well very easy. So I don't have to understand any business logic. I can do this for any company. Okay? So I just read from the source and put it in the bronze. This is very easy. Now, if you go to the silver, I still don't need some big knowledge about the business, right? I read the data. So again, I read the data from the bronze. I just go and start exploring the data to see what are the issues. And those are the typical issues that happens in each project. You will always have white spaces. You will always have some changing of data types, or maybe normalizations of the values. So I don't need here really big knowledge of the domain. I just can explore the table, think about the transformations, and do stuff. Maybe from time to time, I'm going to ask, like, for example, what the S means, what the M means. So maybe I'm going to ask the source system or the business people or the process, but it is not that heavy. I don't need a lot of people to help me on this, okay? So I just clean up the data, and then at the end, go and write it to the silver. Now, for the gold, you just need to write an SQL query to build the model. So here we are building the dimension, then the next one, the fact and stuff. But here, it always depends on how I'm going to present the data in the final step. Now, what's going to happen next? I have the data in the gold, and now I'm going to go and start telling people about it, of course. So I'm going to go and tell, okay, look, in our data, the bronze data is a really crappy data. Now we have a very better, let's say, quality of the data that we have on sales. I have a dimension called customers. Go and start using it. So the data analyst or whatever using with the data, they're going to go and stop using CSV files and their stuff, and they're going to consume the gold table that you have. This has the highest quality of the data. And if you go, for example, let's go and query this table. This is the finest products that you're going to build as data engineer. And of course, you're going to describe it as well. So I'm just going to come back to this point over here. So you're going to say, look to this table. It is very simple. I have here customer key, customer ID, first name, last name. And in the background, it was 3 different files. Okay. So instead of 3 different files, we put everything in one place. And anyone want to do any analytics, or let's say AI, or I go to Genie now and maybe enter the data, they're going to work with this version of the data, the final version. And of course, you have to work on the metadata, of course, in the catalog. So if you go back to you can do it in the scripts, of course. You're going to go to the gold and starts, of course, describing the data. You're going to say, you know what? Oh, I cannot add that. Active computers required. I have to start my server in order to edit the data catalog. So, of course, you're going to start editing the comments and say, okay, this is unique identifier about the customer. I'm just adding here stuff from the AI. And you have to make your data, let's say, easy to understand for you, for the AI. I'm just using the AI to describe, let's say, this table. And with that, your data analyst is going to be very happy to consume this version of data. Instead, if you go back to the bronze, now go back to the bronze, look to the source system, instead of those crappy files. So look at this, it's called customer info. And in the other source, it's called the customer infos. You can see cost AZ12, I don't know, lock A101. It is very cryptical. And this is usually how the sources stores their data, yeah? And you're gonna get the data like this. So it's really hard, let's say, for someone that's gonna start working with the company analyzing the data to work with those CSV files until they understand. So now we speed up, we data engineers, we speed up the analytical process by providing these clean data. So now anyone that starts, they can start on clean stuff, and you have to promote. Now I am, let's say, we call it the product owner of this, and I'm gonna now provide it for the others, and I take care of the correctness of my, let's say, data catalog that I'm providing. Now, of course, what is the next step? I just went now through the scripting, right? So we saw how to script each layer. It's very simple, not that hard. And then we store the data inside here. But of course, now, next day, we will get new data, right? So I will not go each day and going in my projects and starting things manually. So I will not go every day here and start clicking, okay, run all. So loading the new data from the CSV. So, and refreshing the silver. So as you can see, I'm just running the whole thing. So we are just loading the data, everything completed. Then I'm gonna go to the next step where is it? So here, so to the silver and click over here again. I think you understand what I'm trying to say. We will not do this manually because this is not human. So what we're gonna do, we will not do this manually. We're gonna go and build, my friends, something called a data pipeline in order to automate our work. And this is, let's say, the last thing that you have to do is to orchestrate the scripts that you have built. And of course, it is very simple as well in Databricks. There is, of course, another tool that is very, very famous to do the orchestration. It's called the Azure Data Factory. I don't know whether I have here something for it. Data Factory. Ah, yeah, this one. I think you might hear about this a lot. The Azure Data Factory. A lot of companies gonna hire, let's say, data engineers to build their orchestration using Azure Data Factory. And I can say this is not anymore necessary because since last year, Databricks provided now us a new tool called, before we called it workflow, they called it workflow, now they call it jobs. So we can do now orchestration as well inside Databricks. You don't have to go outside. Like I think in the first 3 years, I used Data Factory in the Azure to trigger those notebooks. So I use this to trigger all those notebooks and to build the pipeline, but I don't need to do any more of that. Now we can go and use our, do I have an icon for Databricks? No. So I'm going to use now something called jobs in Databricks. And this is the second, let's say, this is your tool to build now your pipelines. If you see in your projects, guys, this happens a lot. I saw it a lot. I tried, like I was, I played a role as well in the company where I reviewed a lot of projects and tried to give them consulting. And this is one thing that I noticed a lot. People are building in Databricks the whole notebooks and the whole work, but only in the last step, they go and attach Data Factory for it. So don't do that because they don't know that they can do it in Databricks, or they are, let's say, lazy to do that. You can do as well the data pipeline using Databricks. You don't have to jump to a new tool. So it's very simple, very, very simple. All you have to do is to go to the jobs and pipelines and then go to the create and say create a job. So now, again, in the workspace, I connected my GitHub to write my code. In the catalog, I stored my data and built my layers and move the data around. And the last step is the jobs. So I want to do now data orchestration. So create a job, and it is very easy. So what we're going to do with that, we're going to say, I want to run a notebook. Okay. So let's say the first one is the bronze layer. And then I'm going to define where is this, yeah. So it is inside my project. It's inside the Lakehouse. The first one can be the bronze. So this is the notebook. Say okay. There is, of course, some configurations below that in order to configure the server, the stuff. But let's leave everything as a default and say create a task. So this is the first step. Now, what is the next step? Of course, in our pipeline, we have to trigger the silver layer, right? So we can say add task. Again, we are adding a notebook. Of course, you can add some SQL file, SQL query, Python stuff. But usually our code gonna be inside notebooks that gonna run the whole thing. So usually we are running always a notebook, okay? Because even if you use, as I told you here, even if you start scripting using Python files, at the end, you're going to put everything in a notebook in order to trigger those Python files. So, and of course, your pipeline going to be triggering the notebook. So I think there will be no need to use any other, let's say, types. So the next step is silver layer. And of course, here we can have like multiple tables, but now I have only one script or one notebook for it. So now we're going to go and select our silver, say confirm. And the last step, I create a task. So now, yeah, we are here. So as you can see, it's very simple: bronze, silver, and then the last step is our gold. So I'm gonna say gold layer, and go to the bootcamp, then gold layer. I'm just connecting now my scripts. So actually that's it for now. And yeah, usually it's gonna be not a lot of things, yeah? So it's gonna be looking like this: 3 steps. This is my project. And now, instead of triggering each notebook, as I told you, you have to press a button, play, run the notebook. So I can go over here and say run. Now what's gonna happen, it's gonna go and create a job for it, and it's gonna start executing the steps one by one. Let me just see the runs over here. So it is running. So here is the task design, and then in the runs, you go over here and you see what is happening actually. You can click on the run and you can see what is happening. So now, as you can see, Databricks is running the first notebook. Usually the first job takes the longest because it is gonna start the, let's say the server. It might take some time until the server is started. And then the next step is gonna be faster as it spins. So now it is still running the bronze. Of course, you can go inside and see what is happening, right? You can see the steps. You can see here, it's almost done with all steps. Let's go back. So runs. So now if I go to the graph, it is done with the bronze, it is done with the silver, and now the last layer. No, it's not done. It's still running the silver, sorry. So silver is done, and now it goes to the gold. It is running. And it is just creating the dimension of customers, one table. So successfully, very nice. Now, of course, you have a lot of options here to see the graph, how things works. So you can see the bronze layer took the longest. It's not because moving the CSV files was hard. It's just because the server was warming up and starting, you know, because it is, you have to understand, the Databricks, they don't have infrastructure. They don't have, let's say, servers, CPUs, RAMs, stuff like that. They use the cloud from other, from other platform like the Azure and AWS. So in this example, and you as well, if you have the free account, it is using AWS cloud. So that means Databricks has to go start up some virtual machines and warming them up in order to start doing a task. That's why always at the start, it can take a long time because it is communicating to the other cloud. It is starting the virtual machines, and then only then if everything is ready, then it's gonna start. But it's pretty fast, right? So this is not the load time, okay? The loading of the files could happen in a few seconds. Now you can see here the next steps is only 17 seconds, 20 seconds. And of course you can see deeper if you click on each one of them and see exactly where the errors. So now, of course, once I'm done, that's it. I'm gonna go over here and then go to my jobs and then task. And of course, I don't want to click manually run now. I can go and add a schedule for it. So I can go over here and say, you know what, my data comes every day and I want to run it in specific, hourly, daily, weekly. So it depends on how you want to configure it, exactly which minutes and stuff. And you say save. And with that, my friends, it's gonna run every day and it's gonna tell you the next run gonna be around 10 p.m. You can configure exactly where it should start. And actually, this is all what we do. After we write our scripts, we configure the orchestration, we add to it a trigger. And of course, this is, let's say, this is a fundamental thing. This is the main job that we do. But inside, we do as well some extra luxury stuff inside the data pipeline where we add quality checks. Like after loading the bronze, I might add one more notebook to check stuff. if everything is loaded, do we have any empty files and stuff. So I might add in between those layers as well some quality checks, but this is not my main job. My main job is to move the data from A to B and to transform the data and get it ready. But once we have time, then of course, our job is to add some quality checks. Maybe I'm gonna add some logging, some extra stuff, but all those stuff are like add-ons around my core pipeline. My core pipeline is to load the data and transform it. Now, of course, you can go and check the job runs every day. After I made a trigger, I want to monitor, right? So I will not go to this over here. There is something nice called data engineering, and you check every day the job runs. So this is what I do in my project every day. As I'm drinking my coffee, I go and check my jobs. So I check, okay, the jobs ran for only 1 minute. It was successful. Perfect. Then the day is amazing. But if I say here this is not successful, then I will not do anything else until I fix this and run this pipeline. So this is going to be my main job after I build. I have to operate it. I have to check the health of the pipelines, if everything is running correctly or not. And you can do this completely using Databricks over here. You can monitor your pipelines. And one more thing, as you grow with the project, as I told you, I have 20 people on the project, so we have a lot of people. So we added as well some email notifications in the notebooks in order to send emails. Like maybe I get an email at the morning whether everything is okay. I don't want to open Databricks and see the status. So you can start adding some add-ons, some stuff in order to make it like better and better. But the first thing that I have done in my project, I built this for around 20 tables at the start. We were only 2 people, so we built this for 20 tables. It was successful, and as we have more developers and stuff, we started expanding. So I think this is the end, let's say, of this project for now. I'm going to provide you the scripts, of course, for everything, but I want you really to do this project. It is very easy. Maybe you saw me a little bit struggling with the CSV files at the start, but it is really easy to do. Just have this mindset. You have now 6 files in the practice, in the projects. Let me just go over here and start. Sorry, I'm still here. So I'm just saying, just get the shots. So now I'm just saying that, yeah, I'm just checking, sorry. Yeah, get the 6 files from the projects, go through the 6 files from the bronze to silver, clean them up and prepare them, and have 6 tables in the silver layer, okay? After that, try to build a dimensional model where you have 2 facts and one fact and 2 dimensions. If you build it and then build the whole pipeline and run it every day, it's free. It will not cost you anything. And now I think it's costing me some euros because I have now the enterprise edition, but run it every day and have the feeling every day. Wake up and check your project. Everything is running correctly, and you're going to get the feeling of data engineer. You're going to get exactly how we work. And this is all our work. We move the data from A to P, we build the pipelines, and then, of course, start taking things to the next level. How I'm going to add data quality, how I'm going to, for example, connect an API, okay? Maybe how to connect Kafka later. Then go to the next level and start making your code smarter, add functions and stuff. So this is the very fundamental phase that you can do. It's totally doable for you. I just show you an example. And I believe I'm going to do a full project later on this in YouTube or maybe a Bootcamp. Because of course we cannot do everything in one day like this. But I just wanted you to give you the feeling to go through the theory, to have this 3 layers, how I think about it, what to do, so that you get the feeling it's not only theory for you, not only something that we just have some picture about it. And this is going to be your task to build a project. I have the same project, exactly the same files, I built a SQL data warehouse project for it, completely using SQL Server, which is very similar to this, but we are just here using PySpark for it. So the mindset is the same. We take the data, we clean it up. So you can check the SQL data warehouse projects, how I cleaned up everything using SQL. But I'm going to provide you as well the code for tomorrow. I hope that you enjoyed the session. Let me just get the shots to start reading your stuff. So now, window capture. Okay, so now I got your chat and I can see what you're talking about. So now, what's gonna happen next? Okay, so that was actually about the bootcamp that I planned. It was a little bit, let's say, open-ended for me. And I'm gonna give you now, tomorrow, I'm gonna write for you an email with all the steps that you have to do as a task, as a homework. Okay, so I'm gonna define for you as well the project steps, like what to do in the bronze and the silver. I'm gonna give you an example template for you in case you struggled. So that means it is not something that you have to do on your own. In case you struggled, you have a reference, but please struggle with the platform. You will not do anything wrong. It's totally free. So do it, make mistakes, struggle, and then check if you are not able to do it. I'm going to send you the task. I'm going to send you the code. And if you are interested about those sketches, I'm going to send you as well these draws. Maybe it's going to stick for you in your head as a reference for you. Data engineering and Databricks, you cannot teach it in one day. Yeah, I just wanted you to feel confident about how we work in Databricks. It's not about to teach you about exactly each single details inside the Databricks. I cannot do it in 2 days, but I wanted to give you a feeling. So yesterday it was all about the mindset of a data analytics, how to analyze the data. And as you can see, like, I don't know whether you got the feeling. You have to have the fundamentals, the SQL. It is the most important thing, SQL. If you do, or SQL, if you learn it, you can do analytics, and as well you can do engineering. Like the whole gold layer, it's all about SQL. So you can do whole layer on that engineering by completely writing SQL scripts. Okay, then left for you as data engineer, the bronze and silver, and here you cannot use only SQL for that. You have to learn PySpark. And it's only the basics, how to read from file, how to write to a file, and how to do simple operations like trimming, case when, and those stuff. So I think it's totally doable. And once you learn it, then it doesn't matter whether you do the projects in Databricks. You can go and do it in Snowflake if you want. You can do the projects in a different place. At the end, it's always the same mindset for you as data engineer. We take the data, we transform it, and then we do something about it. And I have done this 17 years like this, using Talend, okay? Then using SQL Server codes, using only SQL stored procedures, okay? Then Informatica. Then I used Synapse. Then I went to Data Factory, yeah? And Azure services and stuff. It was catastrophic. I didn't like it. Then I went to Databricks. Now I'm talking about Databricks. Maybe in 2 years, I'm going to start talking about a new tool, but it's always the same mindset. Keep it clean, have an architecture picture, follow it step by step, and load the data from A to B, do transformations. And for you as a data analyst as well, if you are here, it's the same things as well. Yeah, it is whether you are building the, total orders by category in Power BI or Tableau, or in let's say in Databricks dashboard. Doesn't matter the tool. They all have the same steps. So we're going to get the next tool, I'm sure, that is way better than Databricks, that makes our life easier, okay? But we still have to do the job where we do the same steps, but maybe easier than this. Maybe we are writing only to AI. Maybe I'm going to write to AI, check for me, do the trim for this table. But me as data engineer, I'm going to investigate the table and understand the issues and understand the business that I have to add inside the tables. But maybe the AI is going to do the whole thing for me. I don't have to write anything. I don't have to write the trim, the syntax. Of course, you can go and use all the time ChatGPT, but we still have to write now code. We still have to add the code to add it in the pipeline. But in the future, we might not do all the whole thing not, yeah? So we will not use maybe Databricks. We're going to use the next better tool. So the tool going to die. I'm not saying about Databricks, but any tool is going to die all the time because we're going to get the best next thing. But you as data engineer, you have to have the right mindset for it. That's why I don't like making a course or a bootcamp where I just go immediately to the UI. I saw a lot of like courses, I'm not bashing now other people, but they go immediately to the UI and start explaining, click here, and click here, and then you're gonna get the thing. No, you have to explain why we are clicking left and right. You have explained the process, because once they understand it, it doesn't matter the tool. Like, now, if I compare the Tableau course that I have made and the SQL course, I see the SQL course has more value to the community than the Tableau or the Power BI. Because those stuff, the tool's gonna die, yeah? So that's why I invested a lot of time making the SQL course 2 years, because I know how SQL is important for many people. That's why I spent 2 years really sketching and making stuff just to explain this technology for you. But now explaining Power BI, I will not, I will deep dive in it, but the course is gonna die after 1 or 2 years, because we're gonna have the best thing after that. So that's why I'm saying, don't be a guy that is only expert with one tool, be a guy that is expert in the process and how to think like a data engineer. Because it doesn't matter, you're gonna live, let's say, longer in the company, you're gonna be more important. I have a lot of stories to tell you about what happens between data engineers and stuff. But I can tell you, there are data engineers that they think clearly, they don't think about the platform, the tools, and they jump between tools easily in 1 week. Like I can jump now in next, I haven't done a project in Snowflake, okay? But I know the technology, I know how things works behind the scenes, I know the theory, but I haven't done a project on it. But I can do in 1 week a project in Snowflake, or give me, I don't know, yeah, Fabric or whatever. It's all the same ideas. So that's why don't be a data engineer that is expert with only one tool. I saw some engineers that were, for example, in IBM Cognos. I don't know whether you know the tool. They made a lot of courses about the IBM Cognos. They spend thousands of dollars, of euros, just getting certifications. They are the big expert of IBM Cognos for data analytics. Guess what? The tool died. No one is using it in projects. Now, it's going to be, and it's as well emotional. Like we talked to this data engineer, hey, come build a project with me in Databricks. They didn't believe on it because they invested a lot getting into this tool. And it's going to be really hard to get you out from the tool. So I'm just trying to say, be flexible. Don't read every documentation about Databricks. Understand the concept behind it, and then do your projects. I explained now the stuff for you, how to do the project and stuff, but you have to do it in your own. I believe only by doing projects, it's going to work. It's going to click. But I hope you enjoyed the Bootcamp. I enjoyed it myself. Today was harder for me, to be honest, than yesterday, because let's say there was a lot of topics that are hard to explain, and I tried to make it easier for you, but I enjoyed it. So I'm going to leave the video now in YouTube. Tomorrow you're going to get from me some recap email, a lot of content for you in the email. So make sure you are signed up for it. And yeah, I might do another Bootcamp, which is more detailed, where we're going to go through maybe a whole month or only data engineering. So I can take you in each day, maybe in one layer, and then make it slow, and take you to the thoughts on how to promote your code from the junior level to the senior level to the advanced level. So I need time for it, of course, but I think if I'm going to make courses about it, it's going to take time. As you know me, I sketch a lot and take time about it. So that's why I think I'm going to make another Bootcamp. I will see whether it's going to be free. I'm not sure about it, but for sure I will be doing more live content like this. I hope that you enjoyed it, guys. And I am happy to have you here. Thank you so much for being here. If you have questions, maybe I can pick a few questions from the chat now, because I'm looking now to the chat. So if you have anything that's you want to ask, just ask me. I'm gonna check that now. About the certificates, I will not be providing any certificates because this is not sponsored from Databricks. And yeah, it's not, I cannot give you any certificates here. I really think it is better if you go and get certified directly from Databricks. It's way easier for you. The job market about data engineering in Germany, it is, I'm gonna say, things are not really easy like before. But I believe it is for you as data engineer, it is easy, let's say, to find for you a job now. If you push on it, if you have nice projects, if you can present your ideas and your stories and you convince, let's say, the interviewer, then I believe it's not that hard to get a job as data engineer. I believe data engineering now is booming, and a lot of companies have a lot of raw data. They need us to build it. So that's why I think it is totally doable. There is no big difference for you between Databricks, AWS, and Azure. There is like two ways for you to work with Databricks. Either just working inside Databricks without worrying about the cloud, and you can do that. Like for now, I didn't go to AWS or Azure to do anything. I just stayed inside Databricks, and you can do that. But if you take things to the next level, where you want to configure exactly the cluster, exactly the SQL warehouse, the way that you want, then you have to go and start working with AWS and Azure in order to prepare the correct virtual machines. And then let's say to configure the cloud for Databricks, you can do that. But I would say don't get now yourself involved with this, because usually in big projects, you're gonna have a dedicated team preparing cloud platforms for you. And as a data engineer, you don't have to deal with all those stuff. So don't worry a lot about it. Just use Databricks as it is, and it's gonna be fine. The process about how to get involved stakeholders or business people or processes in the projects, it depends on how you're gonna do it. So either you're gonna book a meeting with the guy or the expert. So you tell him or her, you know what, I have an issue in my project. Can you help me with that? So I'm gonna show him the data, I'm gonna show him the script, and maybe I'm gonna get some consulting from him. Or if the project is very important and you have really an enterprise big data lakehouse, then you can start talking to the managers in order to involve completely one expert only helping you building the code layer. So this has happened as well in my projects. We invited to our projects one person from the process, from the business, where he every day help us on explaining things for us. So that means I didn't have to do it as a project lead. Then I always use the experts and fully dedicated helping the data engineer on how to build the logic. And this is something that happens, of course, that's you can get people involved. But if you have small projects, you have like only 3-4 engineers, I don't believe you're gonna get this luxury to involve completely people from the process, because they have better job to do. Now, what kind of work? Okay, a very nice question. What kind of work junior data engineers will do compared to seniors? The answer is going to be next Tuesday. I'm explaining this exactly in the video, but I can give you shortly. As a junior data engineer, you're going to get tasks from senior data engineer, or let's say project lead. And then gonna tell you, for example, go to this table and write a silver script for it. So you're gonna get specific task to do something, okay? And you're gonna ask help maybe from time to time. You know what? I'm not able to understand whether this is correct or not, or I don't understand the data. So the senior is going to help you in order to write, let's say, the code and guide you a little bit, yeah? But your task is always to get a Jira ticket maybe or something like that, do the scripting, and then push your work to the seniors. The senior is going to review your code and then accept or not. Usually there will be some iteration with them. And as a senior data engineer developer, like I can tell you, your main job is to decide on, I'm not sharing my screen, so maybe tell you here. So as a junior developer, senior developer, it is all about thinking about the data architecture. It's as well thinking about complex tasks. Like for example, if you get Kafka now to this project, now we have CSVs, and now I'm going to get a Kafka data. I will not give this new source to a junior data engineer because we didn't have an example about it. We don't have a template. So that's why as a project lead, I'm going to go and give this task to a senior data engineer because this is the first time we are connecting Kafka to the Lakehouse. So the senior going to think about this issue, which connectors we're going to use, how to consume the Kafka, and they're going to start writing the first scripts in order to load maybe one topic, two topics from Kafka into the Lakehouse. And once we have the first examples, then we can now start connecting the juniors and explaining how to connect Kafka because we have already an example. But I cannot go as a project lead and give an advanced, complex, something completely new to a junior because they always need some example about it. So as a senior data engineer, you're going to spend half of your time doing complex tasks, and the other half is guiding the others. So you're going to mentor the others, you're going to help them, you're going to review their work, you're going to maybe reject, accept. So it involves a lot of, let's say, consulting and guiding, mentoring the others. And then after the senior, you might go to data architect, or maybe you're going to lead the project like me. You will not be scripting, you're going to be, let's say, guiding the projects. You're going to be defining the tasks. You're going to be defining the standards in your projects and reviewing as well the data and understanding the business processes and stuff like that. So okay, so now I'm gonna wrap things up. It is already late. I'm tired. I'm gonna go and drink my tea. This time there is no coffee. Thank you so much, guys. Everyone, thank you so much for joining the session. I'm really happy that you enjoyed it. And yeah, wait for tomorrow. I'm gonna give you tasks. Join the Discord. I will be there. I'm gonna be answering your question there. So as well, we have a lot of experienced people in the Discord community. Support the channel. So subscribe, like, comment in order to reach more people like you. And yeah, I'm going to go and build this community. I'm going to go and build the Discord server. I'm going to go and make all those bootcamps and stuff. So I have a lot of plans on my table. The Python course, the Power BI. I'm going to start speaking about PySpark. And so I have a full plan. I'm trying to build, let's say, this community. It's going to be exciting. So help me building this. As you can see, I'm trying as much as possible to do things for free. Believe me, those courses, those stuff going to cost. I'm not trying to sell something, but I'm seeing people charging thousands for teaching Databricks. It's crazy. Like, why is that? So I see a lot of experts charging thousands. I saw another data engineering course, $7,000. $7,000. To teach data engineering. And I find this is crazy because if I was a junior or student, I will never be able to pay this. Even if I am expert, how I'm going to pay for this? So that's why I'm going to say I will try my best to make those stuff free and as well try to benefit a little bit more from the data community, from the data academy, selling courses and stuff, but always with, let's say, affordable amounts. And I want to spread this for as much as I can for people. So, but I need from you to support the channel because, to be honest, the statistics says 70% of you are not subscribing, not liking, and not communicating at all. So you have to give back a little bit in order for me to keep doing this. Otherwise, if, let's say, I'm not growing and I'm not seeing any progress, I have to go back. I have to maybe apply again for Mercedes-Benz if they allow me. I don't know. But if things will not work and I'm not getting the support, but so far the support is amazing, but only 30% of you. So I hope that you can push on the rest, the 70%. So guys, keep supporting those free content, because if you don't do that, they will disappear and you're going to end up only having people that are charging you $7,000 for a data engineering course. Come on. So thank you so much for today. I enjoyed it a lot. I'm going to improve, let's say, from one live to another session. And thank you so much for the mods, for moderating the chat. Have a wonderful day. I hope that you learned today something new. And wait for the email tomorrow and do the tasks, do the homework. If you don't do it, then I'm going to be really sad, because I think the real learning going to happen there. So please do the tasks. And believe me, if you do it, you're going to be adding an amazing skill this year for you. Okay? I'll not say Databricks is going to die in 1 year. Yeah, I'm just saying like it's going to die someday. But keep supporting and keep doing the tasks. And I think you're going to add an amazing task for you. So thank you so much for everything and have a wonderful night. Take rest. And thank you so much for all the love and stuff that I'm